morning, WorkerConf. My name is Tanja. I know it's hard not meeting in person. Getting together as a community is now more important than ever. But regarding the ongoing COVID-19 pandemic, we decided that we should have the talks online only. It's great to see that all of you tuned in. The role of developers is more important than ever. We've seen how critical technology is in this crisis, and all of you raised the game. In these times, you have the opportunity and the responsibility to define what you.
Hi, this is WorkerConf. In the name of all organizers and of all the attendants, I want to thank the sponsors. Tova Digital, a digital agency company from Bregenz. Arculpa, software company from Lustenau. Antelope, a team that is located in Götzis. Gebrüder Weiss, a logistics company from Vorarlberg. Bloom, building most awesome Beschläge for the world. Fusonic, doing Roid software in Götzis. Illwerke VKW, building electricity or delivering electricity. WKO, they are doing their Chamber of Commerce, connecting companies. Wirtschaftsstandardgesellschaft, an organization that is representing our regional economy. Stars Media.
For the speaker announcements, we went outside, just to show you how beautiful our region is. Our first speaker is Pia from Open Collective. When I first saw her at the Zeit Day in Berlin, I thought we need her at our conference. And after some years of trying, it finally happens. This year, our keynote, Pia Mancini from Open Collective.
Hello everyone. Thank you for having me. I'm super excited to be here. I wish I was there with you hiking and riding, but we're still not there yet. We're close, but not there. So today I want to talk to you about the economics of open source sustainability. First of all, hi, I'm Pia Mancini. I'm co-founder and CEO of Open Collective, Sustain, the Open Source Collective, all things Open Collective, really. Yeah, let's dive right into it. So, open source projects are obviously the building blocks of the vast majority of products, services, and digital infrastructure we use today. And as we all know, they're largely made today by unpaid communities. And I think this is a problem, and this is why. This is from XKCD, and it's been doing the rounds lately, but I still find it like so, clear and down to the point. So essentially, this is all modern infrastructure, and it's sustained by a project some random person in Nebraska has been thanklessly maintaining since 2003. So this is more or less where I think we are, and why we are here. So these are the attributes of open source. First of all, open source is a non-excludable public good. It means that it's not scarce. Once it's out there, there is no way of containing its use. You can't exclude people from using something that is open source. The second attribute of open source software is that it has nearly frictionless distribution, or very easy distribution, right, through packaging and dependency management. Third, there is no marginal cost for another person to use the code. There is no cost for the user. The code doesn't care. So another person using that code, downloading that package, has no impact. And lastly, it has asymmetry of information. Producers of open source have zero visibility of who is using the software. So this is creating the perfect storm. And I meant to put a image of a storm here, but it seems like it didn't make the cut. So picture the perfect storm. Open source is not free. Somebody else paid for it. Part of the problem that we have in open source is that the value that is created inside of communities is mostly captured outside those communities. But it doesn't mean that the fact that there is no marginal cost for using open source, or that there is no way to exclude someone, or that it's free or easy to access, doesn't mean that we are not exhausting any resource at all. The problem is that the resource that we are exhausting are the people and the communities that develop these projects. This is Dominic Tarr, who I don't know if you remember, you probably all do. He gave the keys to a project he was no longer maintaining, he was not interested in anymore. He had found better ways of doing and achieving what he wanted to. And so a contributor joined, he asked for the keys essentially to become a owner, and Dominic said, yes, great, sure, why not? I'm not using this anymore, not maintaining it. And this project was widely used by many apps, and the new owner injected malware on the package, producing great damage. And so Dominic got a lot of flake for this, and this is highly problematic because what he said, which I think is like right on point, he says a module is like a piece of digital property, a right that can be transferred, but you don't get any benefit from owning it, like being able to sell it or rent it. However, you still retain the responsibility, right? So you produce something, you put it out in the world, you have no path to get any tangible benefit in terms of like monetary benefit in general, or because of course you get other benefits, like, if you put out there a great piece of software that goes into your, standing in the community, companies will hire you because of that. So I'm not saying that there is no benefit at all, but you can't control what you benefit from, right? However, you always need to retain this responsibility for whatever you've put out there because people are using it. So again, Dominic, you put at risk millions of people, and making something for free but public means that you're responsible for the package, right? So we're in this situation where millions of apps or companies are using software that is created for free by maintainers, that they seem to be tied forever to the product or software that they put out there, because they have the responsibility of it forever, which is extremely unfair if you consider the fact that they're not getting paid for it and they're doing it in their free time. However, I am convinced that our digital commons is not doomed to be depleted. We can successfully manage it. I don't think it's a situation where this is the classic tragedy of the commons. It's more about how we manage these commons. So the first step in successfully managing the product is to acknowledge, the commons, is to understand that separating the code from the communities behind it is just plain silly. Code is the byproduct of a community of any size that exists in a certain environment and that it operates in a shifting landscape. So projects need to evolve, they need to adapt to this changing landscape, and that, my friends, needs people. Even forking a project, sure, you can fork a project, right? So you can, decouple the code by forking, but that still needs people. Someone needs to document, to move the community over to new pathways, communicate about this, etc. So, assuming that a code is just a code in the void, not connected to the people behind it, it's not going to get us anywhere. So the first step is for us to acknowledge this. So this is, your classic supply and demand kind of graph. But so one of the ways that that you can drive up the value of something is by creating scarcity. And the problem that you have with an ecosystem with the attributes that I described earlier is that if your creations are open and accessible, they're absolutely frictionless to distribute. You have no way of excluding folks from using it. There is no cost for the end user to use it. There's no cost for someone else to download the code. So how on earth do you create scarcity? So what is both scarce and in high demand in open source? And that is time and access. For example, what is difficult? If you think about something that is hard to build, to create, creating beauty is difficult. Whether it's tangible beauty of a brilliant innovation or the intangible essence of exceptional leadership, beauty exists in an elegant and novel approach to a problem. But in an industry like open source, like in our ecosystem, beauty abounds. Beauty is the end result of our creativity, of our collaboration, and that is immediately shared, replicated. It's a gift. When beauty is shared, then what is left, right, to be scarce? What can we use to create a sense of scarcity that then can create some sustainability? And that is the time of those with the knowledge. The time of those who created the beauty, who are able to help others enjoy these gifts that they've been putting out there. So how do you create, I forgot I had this slide here. How do you create scarcity? What is both scarce and in high demand? And that is maintainers' time and access, right? This is Mike Sherov. He was at Adobe at the time. And he says giving money to Webpack meant access to Sean Larkin, who was at the time, this was a couple of years ago, co-maintainer to Webpack, and invaluable bundle optimization insights. Giving funding to Babel via employment of LeftPad meant he could launch preset environments which optimized our JS payloads. These weren't donations, these weren't patronage, this was investment, right? So Adobe invested in the open source software they used. It was free, yes, they could have used it for free, absolutely. Anyone was going to tell them anything? Absolutely not. Did they have the right license for it? Yes. What they didn't have was a direct line of communication to maintainers, talking to them, understanding when breaking points were going to come, what the roadmap was, how was the community going, what was the plan for the next year. All of that is invaluable information for companies, and that is why they should be investing in open source sustainability. So, if we can't regulate access to the code, can we regulate access to the people working on the code? Who will maintain the maintainers, essentially? So if the resource here that gets abused is maintainers' time, attention, and well-being. Maybe we're looking at this wrong. The question is not so much how is the source code protected via licensing, but how the people behind the source code are protected. Users are not free writing the code. The code is out there, is free, is accessible, there is no marginal cost to use it. What they're free writing is the maintainer's time and headspace. And that is the most valuable asset we have, because those are the people creating this beauty in the world. So this is one example. This is Fody. They put out there like a pretty radical idea. They said Fody requires significant effort to maintain. As such, it relies on financial contributions from the community and sponsorships. To ensure its long-term viability, it is expected that all developers using 40 became a patron on Open Collective. And they went even further with this. They said that when raising an issue or a pull request, the GitHub ID may be checked to ensure that they are a patron and that the issue or pull request may be closed without further examination if they are not. Again, I understand this is radical, and I can virtually imagine all your eyebrows being, raised here, but I think this is a really interesting experiment. They have like a trust and honest system. They understand that they're PRs, that they're from community members, that they are still going to look at. They're just saying, like, do not think that because you can open an issue for free, we have to reply to it, right? So if an individual or an organization has no interest at all in the long-term sustainability of 40, they can ignore this, right, and use something else. William Gross, I think, sums this up really well. Give away your code, not your time. So what is sustainability? For us, sustainability is about sustaining the community. Maintaining is causing or enable a condition or a state of affairs. This is by Safia Abdallah. To continue, that is maintaining, making something, to go on. But to sustain is to strengthen or support physically or mentally. And so sustainability refers to the resilience and the thriving of projects and the communities and individuals that surround them. And this community has a ton of community imbalances. Posting an issue has zero cost. Companies are hooked on open source. They're not going to start paying for code at this point in time. More people are extracting value from a repo than those maintaining it. Shared code, yes, but there is no shared responsibility. And it's very easy to start a project, but it's very difficult, as we see, to leave it, right? So these community imbalances are creating a pretty, an uneven scenario for communities in open source. Compounded to that, Nadia Iqbal put out a research at the time that shows that increasingly open source projects have fewer maintainers and more casual contributors. And this makes sense, right? Because it's more interesting to start something, put a nice feature out there, than doing the boring task of maintaining. I really like this. There is much more, but however, there's a lot more to a community than pushing patches. No sustainable community can be specific people. Individuals move on for all sorts of reasons. And a project that depends on one person to be sustainable is a project in trouble. We've seen this in Heartbleed. We've seen this countless of times. So we need to figure out paths to make communities thrive. And how do we do this? How do we sustain our communities? So we need funding, right? That's number one thing we need. We need funding. So there are different models for funding open source. You have the corporate models like Red Hat, Open Core, the Linux Foundation kind of model. You can use crypto to avoid legacy system because open source are, projects that are distributed around the world. Most of them have no legal entity. We'll go more into that later. Open source as a public utility. Should we pay open source with our taxes in the same way that we paid for our roads or bridges? Or a decentralized community-shaped sustainability model, which is what Open Collective proposes. Corporate funding has a lot of pros and cons. Pros, obviously, is it's funding maintainers, it has active contributors, scalability. But cons is that it has a ton of government issues. You have the commercial versus community problem. If you have a lot of corporate funding, you have issues with focus as well, because you can have, a request from funders. It can be a threat to resilience and independence. So what we need are open industry standards. We need to have a standard because too quickly it can go to from, for example, opening an issue and the maintainers being able to say, okay, look, I don't work for you, so you can figure it out and they can do something else, to feeling like answering every issue is required because someone is paying $5 an issue, right? So we need like a standardized business terms to avoid the explosion of a contractor complexity between companies and developers, right? Also, because someone is giving $100 a month or $500 a month, it doesn't mean that they can ask anything they want from a maintainer. So we need to work together in figuring out those standards. I'm just going to push a little bit quickly here because I'm just noticing the time. This is a corporate funding index that we created for open source grants. We want to see how much money companies are giving to open source, so there has to be transparency as well. What are the corporate incentives to invest in open source? Companies want to invest in open source because there's a name in the community, they have strategic influence on the roadmap, the open source stack health, hiring and retention, scaling of project, and as we said before, access. So we need infrastructure to support the community as well as the individual members of that community. And that is key, right? We need the community to thrive, the community to be sustainable. Evan from Vue.js says, today as the community grows, there are more and more contributions from the community, and Open Collective's transparent expense model can help us scale financial contributions beyond a single developer. So we're no longer in this case of supporting just one developer with a Patreon account or being hired by a company. We're talking about sustaining a community, making a community thrive, allowing a community to hire, maintain, retain different skill sets. And we're doing it from Open Collective. Open Collective, what it does is we support open source organizations, open source projects, and we interface with funders. So we make sure that project-directed funding can go straight into the hands of the maintainers. We are on a mission to make our communities sustainable. A couple of examples of things that we're doing. We just launched Fund OSS. Fund OSS is, we're very interesting. This is a community project, a collaboration of Sustain, Open Source Collective, Gitcoin, the Foundation, Open Collective Inc. We want to see if we can put a reward on community signaling. So we started a democratic funding matching fund project where individual members are giving funding to communities, and they're being matched with a quadratic funding mechanism that gives more money from the matching pool to those collectives that have more individual donations. We've also created Back Your Stack for a way for, again, this is a community project. This is not Open Collective anymore. We created it and we released it. Back Your Stack scans GitHub organizations, tell you which of your dependencies are seeking funding, and provides you a path, provides companies for a path to have a subscription to all their dependencies. Bounties is another example of things that projects are doing on Open Collective. Hipster.js is a really good example of using bounties to increase their community, to onboard new community members, to put like small bounties to help first-time pull requests. So, using funding to make your community thrive, to make your community more resilient, to invest in all the people. So give contributors a voice on the roadmap. Projects are using the funding to reach out to people with different skill sets, using funding to pay for the tasks that no one wants to do. They invest in face-to-face opportunity, and they acknowledge all contributions. So now that projects have project-directed funding, they manage their own budget in Open Collective, they have the opportunity to grow the different roles, invite folks with different skills to their projects. And in this way, they're not only reducing the buzz factor, but they're also making the community a lot more resilient and sustainable. So we need to come up with a model that distributes revenue, responsibilities, and earned social capital that takes into account different roles and supports different skill sets. So right now, those who make the code or those who make the initial code have a lot of the take home, a lot of the social capital that is created, and the community that stays sustaining that has less earned social capital. Especially roles like documentation, roles like onboarding, design get a lot less social capital from open source project, which means that they have less incentives to participate. And this is it, GitHub's survey from a couple of years ago, but the number one problem encountered in open source is incomplete or confused documentation. The second one is unresponsiveness. And then we have a lot of cultural issues as well with dismissive responses and conflict, obviously. But incomplete documentation is something that is so easy to solve once you have some budget. So things that make a project resilient and thriving and do not have to do with code: documentation, support, community engagement and advocacy, community assets management. What can you do today? You can apply and accept, when possible, jobs at companies that give a portion of their profits to open source. If a company is a good open source citizen and you apply to work for them, tell them that that is the reason, because that makes a huge difference. If you can donate to open source, do it. If you have to charge $1 more per hour of consultancy, give that to open source. If you're a company, obviously invest in open source and talk to your managers. Ask them to contribute. Pressure works, and we need champions in every company. So that's it from me. Thank you very much. I hope that wasn't too rushed at the end. You'll find me at @PMandTeen in Twitter if you want to keep this conversation, or at SustainOSS, and obviously at Open Collect. Thank you very much.
So this year, the WorkerConf is, like most of the events, a pure remote conference. I'm sure the team will do everything to come up next year with a nice event here in the mountains again. So be like Nick, be like Max, come by and join not only fantastic speakers, but also our scenic views, nice people, nice food, and the atmosphere that the Alpine conferences are able to provide.
A few weeks ago, I did a small e-commerce project and I got caught by the sandbox trap. I used the enterprise feature during development, and switching to the smallest plan was not possible anymore. Paying the enterprise rate was also not an option, so I needed something else. I found Vendure and got in contact with Michael. His support is world class. Now enjoy his talk.
Hi everybody, how are you doing today? I hope you are enjoying, you enjoyed, and you will be enjoying the conference so far. I know it's another online conference and we are not in person in Dornbirn. In Austria, we cannot enjoy the Alps and all the activities there. And I really hope that we will enjoy that next time, next year, hopefully. And it will be, we will go there and use the bikes, do some hiking. But okay, don't waste the time, and let's talk a little bit about me. So who I am? I'm the Samuel Snopko, and I'm big headless and Jamstack believer. And I'm going to talk today about the headless and why it's the future of the CMSs right now. So this is a big topic, and you may say like, okay, I'm talking about this because I'm paid one of them. Yes, as you look on me, I am a head of developer relation right now at Storyblock, but that wasn't all the time. Before that, I was working in agencies where like building the website, like every web developer out there. And I was like the front-end guy who was like picky with CSS and HTML and design apps. But I was always have problems because I found a great framework I like Next.js, which I'm a huge fan of. And then I still had a problem with all the monolithic CMSs that told me like I cannot use Next.js really, and I have to use a different technology. So I was looking for something new, and I found many of them, many headless CMS, but then I found a Storyblock and I started talking about that. I was like a speaker about the Next and all different topics about the web, and organizing some events. And at the end, last year, I started working there as a head of the developer relations, and I really enjoy it so far. So don't believe me, I joined the movement of the headless before even I started Storyblock. But that was enough of me. Let's talk and build some basis for this talk. So the big question always is like, what is the monolithic and what is the monolithic versus the headless CMS? So the one part is the CMS, and the second part is, in my opinion, is the monolithic and the headless. So the monolithic versus headless is not only about the decoupling the front and backend, even if that's the main part, but it's also the decoupling all other services from the CMS. So like if you are building the e-commerce, you can build that e-commerce part somewhere. If you have like a authentication system, you can build also that on the side. So like keep in mind that it's like something what is happening right now with the industry, with software as a services, that we are picking the stuff that we really like, and thanks to this stuff we are building the best technology stack what we really like for our users. And thanks to this, our users, not only users, also our developers, get the best experience they can have. Because that's right now the first-class citizen. As far as I saw it, also like Steve Jobs knew that we should go from the user perspective and then back to the technology, and not we shouldn't drive the changes through the technology, but what the users really need. So, and maybe one last point why I think also it's a matter is that we can see this movement also by the big players, like by big traditional CMSs who try to deliver their headless solutions. So that brings me to one more point, and that's the evolution of the CMS. So what really make a content management system a content management system? So it's content management and a system. It's three words. It's not just like throwing somewhere the content. It's that because we had the file systems, and we were using FTP, just moving the HTML files. And yes, for us developers, it's a great way to build a website. It's quite performant, but it's not really like scalable. How you can want to do that, or how do you want to do that with a lot of users, especially non-developer users? And then we brought that idea of like, okay, we need a non-developer features like content outer internet simulation, and even like previews before we're going to deploy something. And that was the great, like we built that big stuff like Drupal, Joomla, WordPress, and it's like from 2004, which I think first was Joomla and then Drupal and then short WordPress. And yes, we were like super happy, but then we find out there's like so many restrictions that we will have to build it this way, and we cannot really change it. And it's like the code is like so great spaghetti code. So we were like afraid of it. So like, okay, what we are going to do with that? So then we can take a step back we are like hoopsing, and we meet like the Git-based solutions. So we had like Git-based Netlify CMS, for example, is a good sample where you take care of files. Again, we don't use the FTP. We are using like repositories and Git for taking the versions of it. But still, it's like there's like we again like say like, okay, we don't need those non-dev features like how to plan and schedule the stuff. So and that when the headless CMSs came to the point, and that's why I think it's important. And those headless CMSs are bringing all those features that are really cool in the traditional CMSs, and we are not saying like they are bad. They're definitely something very important, but we are trying to deliver with same approach as the Git or other, like give the freedom to developers. So literally we are not another Git-based solution. So the headless is not. We are not only for developers. We really focus on the marketers, on the content editors, and all those people, because they are at the end of the day the final users who spend most of the time there in our applications. But still, we don't want to choose the technology stack for you. We just want to give you all the freedom as possible to build your website, your applications in the way you want to. And all with that comes the responsibility that we are not trying to lock you in. We try to be so good that you don't want to leave and make you possible. Like if you want to like, go ahead, it's your content, you just have to export it. You have this everything in JSONs and go if you want. But for me also like really important from, I'm not going to name any names, but you know, like I was like hell that I had that free solutions out there of the CMSs, and then I had to like spend so much time of updating every week because of the security issues and etc. And the list go on. So, and that's why we give you freedom as a headless space or the story block to structure your project as you need, to choose the technologies you like. So also like structure it, like if you want to have a file-based system, if you want to have it like flat structure or folder structure, if you want to choose a GraphQL or REST API, it's up to you. If you want to extend the story block or the headless CMS, you can extend it because we are an application that is easily extendable with authentication and custom apps. And at the end, we try to give you freedom to focus on the solution. And solution, I mean the application and the website that is consumed by your visitors or users or clients. So that you don't have to spend so much time and money on the back end, but you can focus on basically on the front end, if I put it very simple, and build that stuff really properly. And that's why we're taking care of the security, user experience, and user interface of the application where the content editing is happening, the performance of the databases. Also, like if somebody is reporting the bug, we are releasing the bug fixes for everybody, not only like that you have to go and update something. We don't force you to that. We do the non-breaking changes, of course, and you get basically all the updates kind of for free or like in the monthly payment, depends on the plan that you are using. And of course, you getting also the new translations, which is not a small thing. Like a storybook is, for instance, is already translated into the 11 or 13 languages. So your interface is translated and you don't need to have to do anything. Just go to the settings of the user and change it and done. And that's, in my opinion, really important that we can have all those experts on security, user experience, the performance of databases, and maybe change the whole architecture behind the scene without even you web developers or the application developers knowing that, and especially the content editors. They don't care about that stuff. They just need to work on the content. And that also brings me to a very nice quote. One of our users said, like, they, which are coming from the monolithic CMSs, they are usually like new Jamstack. For them, it's very hard to understand and getting their head around anything is possible with Storyblok or headless CMS. That there are any right, wrong, or good answers. This is like all I do also on the question. Like usually I get a question on demo call and then I am like, okay, yeah, there's like so many ways to do it. It's like we don't have one way to do it because of the headless approach. And in the monolithic, you often give like plugin to do that, and you have to do it that way as the plugin does say it. And if you were to like adjust it a little bit, it's getting very complicated and complex, and you cannot do it, or it's like cost so much that you could like build the plugin from scratch by yourself. But in the Storyblok or in any other headless CMSs, it's entirely up to you how you will address those plugins and tools, because you can build your own custom schemas, and you don't need very often extra tools or plugins to achieve some stuff like SEO and stuff like that. And it may look at first like a missing step that we don't have a plugins from for everything, but we have that options. But in reality, it's up to you and very powerful that you can build it as you really need, not as it is told to you, because you have a special needs. And that brings me also to the point that what features any CMS, content management system, should have, especially already in 2021. It's something that you should think if you are building your website or your application, you should consider this, because even if these features, some of those features, maybe you don't need at the beginning, you will need it later maybe. And if it's super complicated or complex to add them to your system, you get very quickly to too high pricing models where you will choose some very cheap solution at the beginning, like a free, kind of free CMS. And then you find out there's like so many missing parts that it's easier for you to change for a different CMS as to like keep updating the existing one. So, and that brings me to the internationalization, which is definitely like a no-go feature. You have to have it, in my opinion. And even if you are not going to translate it right away, but if you want, if it's done correctly, you can have it was basically for free, and it works. Especially with the stuff like Next.js and Next.js or Gatsby, you have it already implemented everything. You just need to deliver it, and like it's few clicks usually and a little bit of coding, and in under the week or few days, 1 to 3 days, you can have a working solution from existing to the multi-language solution. And in Storyblock, especially, we are offering not only like the field level, so we have like 3 strategies for it: field level solution, the folder level solution, and also like translation, and also like combination of those both of them. So like if you want to like change the structures, you would go for folder level, but if you want to translate only the values, then you can like choose which fields are translatable, and then you will translate in all those with even automatizations with DeepL or Google Translate. Great. Then definitely the content authoring, which we are using heavily in Storyblock and other enterprise clients are doing also. And this is not only about like having a drafting review ready to publish. It's about like having a special roles that can choose and change something, that can approve something. So how the approval process works, what emails are sent, what workflows, what are where are going the notification, what is happening if 2 editors or content editors, marketers are editing the same story. So how they are looking itself. How they can compare it, how can they comment on the field level, on the whole story level. So that's a lot. And then of course, content scheduling. Very well plan a schedule of bundle of the changes for the weekend for a special game. Like we have a Euro 2020. So you want to have like a special offer for this weekend when the Austria plays against somebody. And then you want to offer like, hey, everything it's going to be for free during the match. That's it possible because you just can schedule it. And then of course, like we have those enterprise clients, those big clients who want to have a security, like they want to be secure that if something goes public, then it's public all the time. And it's secure, and it's sure that it's not happening and nobody can just like that change it. So that's why we have a pipeline where you frozen your content and you just get it from staging through different stages. And in live, you know very, very, very clearly that what is live, it's already approved by anybody from CEO down to the like last employee. And the reusability. This is the part where we are getting with Next, React, Vue.js, Svelte, Java, all the JavaScript frameworks, PHP even, etc., etc. And you know, like the approach is like atomic design or component approach. So when you can reuse different components through not only your sys1 project, but even in the different projects. So you define a content types and then the nestable components, like you can nest it so deeply as you need. So basically it's a never ending nesting, and using this approach and combination, you build what you need and how you need. And you can of course like export it, save it into your repository, and then you have like for the next time new client comes, you have already like almost done the project because you just duplicate or clone the repository, push everything in the Storyblock, and you can work like that. Then of course extensibility, which I talk about, and this is like huge thing because a lot of people think that we are not able to like extend headless solution because that service software is a service, but that is not true. You can build your own plugins, not only plugins, you can build like own type of field types, you can build your own plugins, you can build your own applications instead of with authentication there. You can build your own scripts with tasks that is triggering through different webhooks or different events, and all of that with combination with tools like Optimizely, Cloudinary, N8N, and other automatization tools or Zapier. You can get basically anything you want, just choosing and picking the right tools to do the job. And of course, integrate with any e-commerce. So, and thanks, and this all, it's of course possible because we have, and every headless CMS should offer management API where you can edit all the stuff, all not only through the UI, but also in the code, and migrate and export everything you need. So that brings me also like image service. Like of course, what I should tell here and more, like it should have an image service, at least the basic one. And if you need super complicated stuff or complex, then go for Cloudinary and integrate it, which we have already also let integration ready for you. So that's it. Like Just use it and it's done, working. And the community, which we hope that we have a great community, at least already here in Austria, there are like a lot of people using the Storyblok, also like in other companies, we have great ambassadors, and they all are happy to help you because they're all fans of the headless Jamstack, the Next, React, Svelte, and then the community is helping each other. And that's how we are all growing. So it's not fighting against each other, but helping to each other. Also through the other headless CMSs and how the Next and Next work together. And what we think is also super important and upcoming years, especially like now already, is the real-time edit visual editor. And what I mean with real-time edit visual editor, I don't mean like to have a preview of something. I mean like something which you really use, like clickable preview with shareable URLs, with previews on different or sizes or resolutions. And I have a like quick demo. What I mean is like, this is the simple Hello World website I just could build. And you see like, these are my components like teaser, grid, and I have here even the possibility like click here on the different stuff. I see like, okay, this is a feature, this is a grid, this is a teaser. And if I click here, the right content here, so look here, it's opening on the right hand side, and I can like edit it like hello WorkerConf. And then I can like also have context changes. So like, hey, move this forward, and we are changing the position here forward, or I can click on the grid, then select everything, copy paste it, add it here, just duplicate it, my stuff. Then, okay, let's see how does it look like on the mobile, maybe on tablet, or like let's go very responsive. And why I think like this is important is like, because if I want to experiment and my marketers and content editors want to experiment with the different stuff, like they want to copy paste the stuff, like create a very quickly new website, new experiment, they would usually have to always click and save button to see the deployment and see the preview of what they created. But this is like so unhandy sometimes, because you click and save and you're creating a new version in your system, in database. And right now, if you guys look on the versions, I just created a new version here, like my new current version. And if you imagine that I always click have the save button as I do a little change, I would have so polluted my history. So that's why I do only the changes when I already like do changes, look if it's looking good, and then hit the save if I'm really happy with my result. And then I very quickly again get back to the original version. And then of course I will publish only that I am like really happy with. The webhook is triggered and it's net deployed to Netlify, Vercel, AWS, or whatever, and wherever we want to deploy it. So that's why I think like the real-time visual editor, which works with Next.js, Nuke.js, JavaScript, PHP, for all those technologies, that's something what we really need in all our CMSs, and our marketers, they love it. So go for it and check it out. Here is like the link where you can start with Storyblok, storyblok.com/technologies, where we have this great technology hubs. Maybe you can also speak with the people behind the WorkerConf, how they build their website with the Storyblok and how they like it. And that's it. Lastly, I always want to thank you. I want to thank you, the community behind the WorkerConf. I want to thank you, the community and the team behind the Storyblok and behind the headless, behind the Next.js, the Vue and React, because these all are the people that are investing their time and building the stuff that we as the speakers have opportunity to present. So we are maybe getting that cherry on the top, but you know, like there are like many great people behind all of these tools. So I want to thank you. And also, if you have any questions, there would be a time for questions right now. I'm not sure right now where the questions will be, but definitely don't worry. You can get me on the Twitter, so Samuel Snopka on Twitter. Follow me and write in DM. I'm happy to answer any questions, or follow the Storyblok, and we are happy also like to chat about anything there. Or join our Discord, and you can find me also there on the storyblok.com website. You will find a link for our Discord community. And that's it. Ask questions, and thank you very much to having me, and enjoy the rest of the conference. See you soon in person. Ciao.
A very warm welcome to Simona Cotin. Simona is developer advocate at Microsoft, and more than that, she's a regular speaker at WorkerConf. So we're truly excited that she made it this year. Follow her for her talk and connect with her on the social media platforms. And other than that, be sure to ask her questions about serverless technology. The Microsoft platform is investing a lot into making the developer experience smooth and easy when it comes to open source and specifically serverless technologies. So with a very warm welcome and an exciting greeting, I'm wishing a great day and say, let's clear the stage for Simona Coutin and let's not fall down the mountain.
Hi everyone, welcome to the session, The Serverless at the End of the Universe. A race of hyper-intelligent, pan-dimensional beings once built themselves a gigantic supercomputer called Deep Thought to calculate once and for all the answer to the ultimate question of life, the universe, and everything. And for 7.5 million years, Deep Thought computed and calculated, and at the end announced that the answer was, in fact, 42. And so another even bigger computer had to be built to find out what the actual question was. And this computer, which was called Earth, was so large that it was frequently mistaken for a planet. Sadly, however, just before the critical moment of the readout, the Earth was unexpectedly demolished by the Vogons to make way, so they claimed, for a new hyperspace bypass, and so all hope of discovering a meaning for life was lost forever. And for those of you that are not familiar with this story, it's actually from The Hitchhiker's Guide to the Galaxy. And the author of this really amazing series of books is Douglas Adams. And I'm pretty sure that secretly he was a huge fan of serverless. And let me tell you why. Here's a few common patterns and challenges that are serverless related that I can immediately identify in the previous paragraphs, in the previous story. There seems to be a few challenges that are related to maintaining states. We were able to compute the answer to the ultimate question, but then we had to recompute what the actual ultimate question was, which is odd, and it hints at us this lack of being able to maintain state. In between the lines, it sounds like we're looking at a coordination of long-running tasks. And hey, the Vogons destroyed the planet just before the readout. And if this doesn't sound like a function timeout, then I'm not really sure what does. And in fact, I'm pretty sure that Douglas Adams is one of the first thought leaders that came up with this set of recommendations and best practices for serverless. Functions must be stateless. You cannot rely on state being preserved in memory from one call to another. The cloud providers actually count on this to ease provisioning and add fault tolerance. Functions shouldn't call other functions. In fact, functions should do only one thing and abide the single responsibility principle, which states that every module, class, or function should have responsibility over a single part of the functionality that's provided by the software, and that responsibility should be entirely encapsulated by the function itself. And how you separate functionality into functions will actually determine how your application scales and impacts your deployment strategy. You must find the critical components in your application and make sure to isolate them in separate functions. Now, all these best practices and recommendations, they put us in a very challenging place when it comes to building complex applications using serverless. Realistic applications will need fast access to data and state. And these constraints actually force functions to access data, all of the data, remotely, and it forces them to externalize all the state into remote cloud storage with the goal to preserve it across calls and pass state to another function. Currently, two functions can only communicate through an auto-scaling intermediary service. And today that means storage systems like Azure Blob Storage or Azure Cosmos DB that are radically slower and more expensive than point-to-point networking. And you might know me, my name is Simona Kotin, and you might know me from organizing Serverless Days London. I'm a pretty active member in the serverless community, and I've authored a Pluralsight course on the topic of building serverless APIs. I've also helped out with organizing Serverless Days Boston. And if you've encountered the 25 Days of Serverless challenges, I've been part of that project and came up with the idea itself. My name is Simona Kotin, and I'm a cloud developer advocate at Microsoft, and you can find me on Twitter at Simona_Kotin. Please reach out if you have any questions related to serverless, building web applications, and generally deploying your applications in the cloud. So let's have a look at a simple example. Imagine we need to implement a two-factor authentication feature. What we need is a basic workflow that allows us to generate a random code, send that code to the user's secondary device, wait for the user to send it back to us, and then verify that the code is the one that we actually generated and it was provided within the suggested time limit. And in practice with serverless, we would have a function that generates the random code, sends a text via maybe a Twilio API, saves the code in a remote storage account, and then we would have to create another function that gets triggered when the code is actually submitted. It reads the user code from storage, checks that time limit wasn't exceeded, checks that the code is correct, and returns the user data. And even with this very simple task, we had to access remote storage at least twice. And of course, that has an impact on latency, which results into poorer end-to-end experience and end-to-end performance. It also adds complexity to the developer productivity. It's now much harder to reason and visualize our applications. Now we need to understand what's the relationship between our functions and our storage account, maybe our queues or data stores. And when we look at a flat list of cloud resources, it's a lot much harder to figure out how all of these work together and what's the relationship between the two. And in the controversial paper, Serverless Computing One Step Forward, Two Steps Back, the authors argue that one of the biggest architectural shortcomings of the functions as a service platforms is the fact that they essentially implement a data shipping architecture. So serverless functions, they run in isolated VMs or containers, and they separate from the data itself. And in addition, functions are also short-lived and they're not addressable, so their capacity to cache state internally for repeated requests is actually limited. Hence, with serverless, we are shipping data to code rather than shipping code to data. And this has implications in latency, bandwidth, and eventually cost as well. And as the paper states, this is a recurring architectural anti-pattern among system designers, which database aficionados seem to need to point out each generation. And of course, there's a lot of research that's being done at the moment to push the boundaries of how we manage state in serverless. And I'd like to spend a few minutes to highlight two different solutions that I think you're going to find quite interesting. Narrowing the gap between serverless and its state with storage functions is a paper that introduces a fix for data shipping architectures. And the paper describes Shredder, which is a low latency multi-tenant cloud store that allows small units of computation to be performed directly within storage nodes. And this is by no means a new idea. On the mainframe, we used to call it function shipping. In databases, you probably know it as stored procedures. And the key goals of Shredder are tenants should be able to embed arbitrary functions within storage, and those functions should have seamless access to the tenant's data. A tenant should not be able to see the code or data of other tenants, making the isolation principles very strong. Support for thousands of tenant functions with fine-grained resource tracking so that we can maximize resource utilization. And then, of course, another key goal of Shredder is ensuring high performance for these serverless functions. And internally, Shredder consists of 3 different layers. We have a networking layer, a storage layer, and a function layer. And each CPU runs all 3 layers, but CPU cores follow a shared nothing design. And the state of these layers is partitioned across CPU cores so that we can avoid contention and synchronization overheads. And the storage layer hosts all of tenants' data in memory and has a key or a get put key value interface. And the network layer handles network connections, protocol processing, and the requests for all tenants. And for each incoming request, it calls through to the storage layer if the request is a simple get or put operation. And if a request specifies a particular storage function, then the network layer calls through to the function layer. And finally, the function layer matches incoming requests to their storage function, code, and context, and it executes the operation within a per core instance of the V8 runtime. Cloudburst is another very interesting solution which uses the more common data shipping to bring data to caches that are next to our function runtimes. And the key ingredients of Cloudburst are highly scalable key value store for persistent data, which is called ANA, local caches being co-located with function execution environments, and then cache consistency protocols to preserve developer sanity while data is being moved in and out of those caches. And the key goals for Cloudburst are that a running function's hot data should be kept physically nearby for low latency access. Updates should be allowed at any function invocation site, and cross-function communication should work at wire speed. And the programming model that's being used by Cloudburst is Python. And interestingly, the paper also introduces the concept of logical disaggregation and physical collocation. And auto-scaling in serverless platform is enabled by the disaggregation of storage and compute services. And this allows the compute layer to quickly adapt resource allocation so that it can meet workload requirements. Disaggregation is needed to provision and build storage and compute independently, but with Cloudburst, the goal is to deploy resources to different services in close proximity, physical proximity. And there are 4 key components: function executors, caches, function schedulers, and a resource management system. So user requests are received by a scheduler, which then routes them to function executors, and each scheduler operates independently, and the system relies on a standard stateless cloud load balancer. Function executors, they run in individual processes that are packed into VMs along with a local cache per VM. And the cache on each VM intermediates between the local executors and the remote key value store. All all Cloudburst components are run in individual Docker containers, and Cloudburst uses Kubernetes simply to start containers and then redeploy them on failure. And these solutions, they optimize for low latency and fixing the data shipping issue. But another challenge that we mentioned in the beginning was the ability to coordinate long-running tasks. And this is another type of state that we need to maintain. A second class of use cases leverages serverless functions simply to orchestrate calls to auto-scaling services such as large-scale analytics or even machine learning APIs. So let's have a look at an application that I've built recently, which is inspired by the incredible Parks and Recreation TV series, which I hope that a lot of you are familiar with and also love it because it's such a great TV series. If you haven't watched it, I highly recommend it. And my goal with building this application was to showcase how we can use serverless workflows so we can train machine learning models. In many of the use cases that you will hear about serverless and machine learning, most of the time serverless is being used as a prediction API, so deploying a model and serving an endpoint where you can serve predictions. But in this particular case, we're going to use serverless so we can train a model, which is a novel way of using serverless with machine learning. And in Azure, we have a product that's called Custom Vision AI, which allows you to run computer vision predictions by building custom models using transfer learning. So basically, we're benefiting from all of the Microsoft machine learning models that have been built over time, and we can take those models, existing ones, and build on top of that a custom model which will allow us to give return predictions that are specific to our particular use case. And to do that, we need to go into Custom Vision AI and create a series of tags and upload images for those tags. And if you're going to try Custom Vision AI, you're going to see that usually you need about 20 images per each tag that you're creating, and each tag needs to have images associated. And this gives you an example, this gives you a clear understanding of how powerful transfer learning is. We no longer need to have hundreds and thousands of images to train our models, but rather a few data, a few images, and a smaller data set can be used in order to build custom models through transfer learning. So once we've created those tags and we've uploaded images for those tags, now we need to train our model. And then it gives us an API where we can use which we can use to make predictions. So for the Spirit Dog application, I'm taking an existing data set of images of dogs that are published by Stanford, which you can find on kaggle.com. And we train a custom model and then upload a picture of a human like myself or someone from Parks and Recreation to see what's my spirit dog or what's their spirit dog. So basically drawing a series of similarities, trying to find similarities between the picture of a dog and the picture of a human, and predicting which dog breed do we look most alike. That's a fun one, right? So I can run tests very quickly within the user interface here with Custom Vision API AI. So when I upload a picture, I get in return a list of probabilities for what is my, or in this case, Tom's spirit dog. And you can see here that his spirit dog is a Silk Terrier. And fortunately, we also have an API that allows us to run model training steps, all of them using code. So as opposed to manually creating all those tags and manually uploading all the images that we have, which are in the number of hundreds, we can actually use code and a REST API that will do all of that for us. So given the data set with dog images, we'll iterate over each dog breed, which within the data set that we have is actually a folder with the name of the dog breed. And then we create a tag using the Custom Vision AI REST API. And then we upload those images to the Custom Vision AI endpoint. And once all tasks are completed, then I want to go ahead and train the model so we can run predictions. And before we go see the code to see how this is implemented, I want us to look at some of the properties of orchestration systems. And this paper diligently documents a comparison of existing function as a service orchestration systems. And this is a great resource to help inform our thinking when we start evaluating different options. And they take into consideration several important metrics, but we'll look into more detail at only 3 of them. Please go ahead and read the paper to get a better understanding of all of them. So the first metric that we should look into is the programming model. As a developer, I care very deeply to have, when I'm writing code, I care about having access to the programming constructs that I'm usually used to. When we talk about programming model in this paper in particular, it refers to programming simplicity and the set of coding abstractions. Architecture tells us whether the orchestrator can be an external entity, not implemented as a function, so a client-side scheduler. or as part of the runtime itself as a function scheduled in reaction to events. And then state management tells us how data is being passed from one stage of function composition to the next. And I'll use as an example Azure Durable Functions, which is an extension of Azure Functions that lets you write stateful functions in a serverless compute environment. And the extension lets you define stateful workflows by writing orchestrator function, which using the Azure Functions programming model. And behind the scenes, the extension manages state, it manages checkpoints, and it restarts for us, allowing us to focus on the actual business logic and what we need to accomplish. And with Azure Durable Functions, we can define workflows directly in code using C# or JavaScript code. And the programming language and the programming model, it supports really powerful abstractions like function chaining, retries, parallel spawning, like fan-in, fan-out pattern. And it also provides a complete reflective API that allows querying the current state of a given orchestration. It allows us to also trigger events so we can await orchestration instances or even terminate them if we need to. Its software architecture is an extension of the reactive core, and specifically the architecture is based on Durable Task Framework, which enables development of long-running workflows using a pattern that's called event sourcing. And this pattern, it stores all events produced by function calls and enables the event replay to restore a previous state. And all of the events are stored using queues, tables, and blobs. And the key benefit of this approach in particular is that the orchestrator function can be hibernated and later restored. Using event sourcing, the orchestrator function is replaying its state every single time an activity function returns. And this means that the orchestrator function code must be deterministic. So we're not allowed to make I/O calls or use a timer in our orchestrator code, but rather we should be using existing patterns that are being implemented within the framework itself. And state management in this case refers to how we pass state between functions. We already mentioned that. In Azure Durable Functions, it does not restrict the size of state parameters that are being passed across functions. And because this information is logged for fault tolerance, Azure Durable Functions stores the parameters that are larger than 60 kilobytes of data in a compressed form so that it can avoid overhead penalties and reduce storage costs. With durable functions, there's multiple types of functions, and the two most common ones are the orchestrator and the activity function. So orchestrator functions describe how actions are executed and the order in which they are executed. And an orchestrator or an orchestration can have many different types of actions, including activity functions or sub-orchestrations and timers. And activity functions are the basic unit of work in a durable function orchestration, and they're very similar to the regular serverless functions. And this is where we do all of the non-deterministic work like I/O work, or we can use timeout functions. And the third type of function is the client function, which can be an HTTP triggered function and is responsible for restarting or starting the orchestration execution. And going back to our Spirit Dog application, this is a schema of how our orchestrator looks like. We start by running an activity function that retrieves the list of dog breeds and it returns it in the form of an array. And then we iterate on each item of the array itself and kick off a concurrent list of sub-orchestrations. And this is where we chain two different functions that are responsible for creating the tags in Custom Vision AI and then uploading images for those particular tags. And once all of these tasks are completed, then we execute another activity function where we train our custom model. So I've talked a lot, but you might want to see a bit of code as well to understand how you can write functions and create orchestrators and activity functions. So let me just go ahead and show you a basic orchestrator and then an activity function. And my universe is my eyes and my ears. Anything else is hearsay. This is another cool quote from Hitchhiker's Guide to the Galaxy. So you're going to be able to find this code at github.com/simonaco/spiritdog. And I'm going to make sure to share those links towards the end of the presentation as well. But here's a simple example of an orchestrator which is implemented in JavaScript. So you can see here that we're using a durable function orchestrator that receives a parameter, as a parameter, a context object. And then we call our first activity, so context.df.call activity, and then we in the first parameter to this function is actually the name of the activity function, which in our case is get breeds. Then we provision a list of tasks and we iterate over each breed, and we kickstart concurrently a series of sub orchestrations. And then when all of these sub-orchestrations have completed, then we call a last activity function, which is train model, which basically allows us to train the custom model, which we can then use to make predictions. And this is an example of activity function that creates the tag for us. So you can see here that, again, it's a JavaScript function that receives a context object as a parameter, and then in the create tag function, we basically make an HTTP request to an endpoint for Custom Vision AI, where we send as parameters the name of the breed that we want to create the tag for, and then we return either an error or the name of the tag itself. So this application, Spirit Dog, as I mentioned earlier, is available on GitHub. On my profile, it's called Spirit Dog. And then I also want to call out a different application that I've been working on, which is called Durable Days, which is basically an application that allows you to schedule API calls with different parameters and a different payload at a custom time. This is another common use case for durable functions, where whenever you want to schedule, let's say, call to an API 5 hours from now, or 2 hours and 31 minutes if that's required, you can use durable functions timers for that, and it's coming in quite handy because the framework itself has implemented support for all of that. So we've looked at a few examples of how you can implement stateful serverless, and I guess that my message currently is that you should pay attention to this space. Serverless doesn't have to be stateless, and there's a lot of work that's being done at the moment, both in the academia as well as in the enterprise and open source space, that help us, or with the goal to help us overcome some of the initial challenges related to this. And I believe that serverless has a lot to offer, and I'm truly grateful that it is here to help us build products faster and at the fraction of a.
Our next speaker is Nick. Nick is a supporter of Alpine conferences since the beginning, talking about React VR, serverless, or showing his skiing skills on the Agent promo video. And what he is able to do tomorrow on the bike and hike, you know if you follow his Strava profile. So, now enjoy his talk.
Hello, I'm Nick, and today I'm gonna tell you a lot about end-to-end encryption and why I care. Let me first talk a little bit about end-to-end encryption and define it, what it means. Well, end-to-end encryption basically means you have a system where only you and other participants can read the actual data or the messages. So basically, as soon as a message, or even before a message or data leaves your device, it's encrypted. It gets sent to a server, can be stored completely encrypted in a database, and then possibly even like sent to the recipient, or even again received by you, and only the recipient can decrypt it, or only you can decrypt it, and nobody else in between. Nobody that intercepts traffic here, nobody that owns the database can actually see the content of the data. And before we go into a lot more technical details and why and background, I want to take you a little journey. Think about the future. Our society in maybe a couple hundred years might look like this, like beautiful skyscrapers, lots of green areas, basically an utopia. Everybody's healthy, and we're colonizing various solar system, and of course we're flying cars. But I want you to focus on one little detail, specifically, like what happens if you send a message to a friend if you live in this utopian society. What do you think would happen? What do you think should happen? Is the message, like, who can read the message? Is it end-to-end encrypted? Can you and only the other participant read the message? Or can the UN, which would be the big government caring about humanity, could they read the message? Could anybody else, like a successor of Google, the big mega corp that then exists, still read the message? What should it be? And for me, like, this is there's an obvious answer. Like, it should be, I mean, we should care about privacy, and the message should be encrypted. And end-to-end encrypted, meaning like I can read the message and the other participant, my friend, can read the message. That would be nice to have, like, if this is the default way of exchanging messages in the future. But what about today? Well, if we look at various tools to exchange messages like Slack, Discord, Messenger, SMS, or even email, like, the providers can always read the messages. I mean, there are some exceptions with email, and Messenger has a secure mode, but all in all, like, by default, the service provider of this service can read your messages. They basically can know everything that you talk with someone else. It gets a bit brighter for iMessage or WhatsApp. They cannot read your messages, but there are some gotchas. I mean, the code is not open source. We can't verify that this is actually the case. Possibly we can reverse engineer things, but with every update we need to check, is this actually the case, and we can't verify the code and so on. And with iMessage, the encryption is not that strong, and you only make a handshake once, and so there's a couple of gotchas. If you look at applications like Signal and Element, these providers, they can actually not read your messages. That's fantastic, and the code is open source, and you're pretty good. That's fantastic. But now you might think, like, wait a second, what? Are all these other tools like Slack, Discord, and so on, are they completely insecure? Well, not really. Let me elaborate two terms, or two terms basically, why they are still secure in some sense. Basically, they have encryption at rest. Encryption in transit, which basically means they establish security, like, from the device to the server, and then from the server to the device. And this means, like, at least no one on the network, on the internet, can intercept your messages, because as long as they are doing a good job and are not hacked, basically your data is only received by the other recipient and no one else, obviously except the service providers. And so this is encryption at rest, and by today standard, this is like very much a default. Like everybody is using HTTPS to send messages. If they don't, I would be very troubled. Or if you're using a service that doesn't use HTTPS, you really shouldn't use it anymore. And probably like these service providers like Discord and so on, they do even like one more thing, which is encryption at rest. So they even care about like, well, your server still, when passing through the data, still has access to the raw data, to the plain text data. But when you store it in a database, the database itself, the hard drives and so on are encrypted. And this means like even if someone actually goes to the data center, steals the database, they couldn't do anything with it because it has a strong encryption, and yeah, you can't leverage the data. In the end, so this looks pretty good, but still we have the problem here. Like they run code and they can decide what to read, I mean, they can also read from the database and decrypt everything with the right encryption keys that ideally are stored in some other secure database. But yeah, it's still a thing, like it's possible. And yeah, with end-to-end encryption, it's not like, if everything is sound, if the technology is sound, the cryptography and so on, like you don't even have the possibility. It's really nice. You just encrypted your device and only the other participant can decrypt it. And for me, if you think about like going to our utopia, this is fantastic. This is really great because we have a bright future ahead. We are already doing what we think of, like where we want to be, and that's fantastic. But let's move on to so we have this for messaging systems, but what about shared documents? Let's look at providers like Microsoft 365, Google Docs, Notion, Confluence, Apple Notes. All of them, these are systems where the providers can read your data. They probably do, they definitely do encryption and transport, and they most likely do encryption at rest, but we don't know the code, so we can't prove it or can't validate it. But what if you start to look for like shared documents, shared data? If you look for if you want to have something where your provider can't read your data, and this actually is the situation looks very dire nowadays. You basically won't find much. I mean, you could share something in a password manager, or you could be you could use like GPG to encrypt and put this content into a word, but then all the collaboration and fun goes away. Yeah, so in the end, unfortunately, this is not so great, and to be honest, it gets even a bit scarier because if you look at all, like almost everything nowadays is just encrypted in transit and addressed. Like if you look at electronic healthcare records, this basically like someone has access to it apart from you and possibly your doctor, and like even if you think about like, well, then I use a system from a small startup, but in the end, like most of them are just hosting on AWS, Azure, or Google Cloud, and well, in the end, AWS, Azure, and Google Cloud, they if they want to, they have access to most of the data. it's kind of scary. And like, I mean, it even goes so far that if you do an iCloud backup of your iPhone, it is unencrypted. Well, it is probably like very likely encrypted address, but Apple can restore your phone at any point if you're using iCloud backups. That's kind of scary because like everything that you put there, well, not everything. As an app developer, you also have the choice to like make sure some data is excluded of the backup, but then also people are can be very unhappy if like if you have a document and you back up your phone, but then if you restore it and it's not there anymore, that's kind of scary. Anyway, is all hope lost? No, I mean things are getting better. Like if you think like back 20-30 years, we didn't even have encryption at transit everywhere. Like nowadays it's like a default, and that's fantastic. And encryption at rest is also now like it's getting more traction with better systems, and things are evolving, and this is really nice. But yeah, we still have this this problem, and that like we could use end-to-end encryption. I mean, we are at a point like some companies, some products, and some tools are already doing it, like Signal, Element, and so on. They do it, and they do it in a really good way. So why can't we have this, or why don't we have it for a lot more data, like our health records? Well, the thing is, well, I don't know exactly like what's the exact reason. It's probably a mixture of multiple one, but like the possible reasons are this is still a very young field. And I mean, if you think about like end-to-end encryption is very young in itself, and applications that are applying end-to-end encryption, they're just evolving, and yeah, we are not there yet. But still, like, why messages and not other data? First of all, like it's harder to manage the data. If you think about like debugging an encrypted message, this is way harder. Or like if you want to do migrations of the data, it's very tough because you basically can't. You have to support it a long time, or then you have to make cuts. And it's also like if you run a server and you want to verify or process data, you can't anymore. Suddenly it's like everything has to happen on the client, on the device, or basically where the user is. Can be the web browser as well, but still, like it has to be like at the ownership of the user, at the device of the user. Also, another problem is like data is valuable for a lot of companies. Like, I mean, yeah, you want to have analytics and insights. It helps you develop a product, and it's very important. But still, there's a mismatch of interest, yeah? Because like knowing everything about your users, like often users don't want that. On the other hand, for companies, this and for product people and so on, like this is very valuable information. And yeah, and there's even like this idea or notion of like data is the new oil. The more data you own, you will be able to leverage it and use it. And there's one more point that I find very interesting. It's really hard to do collaboration on the same data. What do I mean by that is because basically, like if you have messages, it's very easy, you know, like a user sends a series of messages, and you can just, if they're not editable, like you can even make them editable, but like the thing is that you just apply them in a list, and that's fine. And then you just have to record the timestamps, and you check that they're correctly ordered, and that's easy. But what if you do, let's say you have a Word document, and we both edit it in parallel, and then we send it to a server? Like, I mean, an easy solution, and this could work out. It's like last write wins, and this is like often in databases and distributed systems is like a simple and common strategy of resolving data conflicts. It's like whoever writes last wins, but that means a lot of data, or a lot of data could be lost, because you have no way of merging the data on a server, and that makes it really tricky. And another system to actually deal with that, the first paper came out, or implementation came out in 1989, is operational transform, and Google Wave first used it 2009, and Google Docs is actually using it today, and it's a fantastic system. Everybody knows this experience when two people work on a document, and you just write, and you could even be offline for a while and continue to write, and the other person can do the same, but in the end, like, both all of your changes will be there from both people, and that's fantastic. So this is like conflict resolution done well. The only problem with it is it usually needs a server to do the conflict resolution. Well, basically you need just one instance of, like, one authority that can actually say, like, this is the resolved version, and some people are attempting this with blockchains and so on. So it's possible, but it's really, really tricky, and it's kind of complex. So people are not too happy about it. But 2011, something very interesting came out: conflict-free replicated data types, CRDTs. And since then, they have seen a lot of adoption. In Redis Enterprise, in Figma, and even in Apple Notes, CRDTs are used to resolve these conflicts. And there's one thing that makes it especially interesting. It's fine to resolve conflicts only on the client. You can do this. The system works in a way that you don't need this, like, central place to actually combine the state. And for me, I realized this, like, I don't know, 2 years ago, a bit more than 2 years ago, and I was like, at that moment, I was completely mind blown, because, well, if you can have conflict resolution at the client, suddenly, like, you can have shared data, collaborative data, being resolved, which means it enables end-to-end encryption. And this was fantastic. In theory, this was amazing. The only problem for me back then, well, I had no idea about CRDTs. I've never worked with them, and I've never worked with end-to-end encryption. Fortunately, I don't know, it happened like a couple months later or so. So I like the idea, but, like, this was completely way out of my reach. I got a new gig, and at this gig, I mean, I took it on purpose. I was thinking this would be the right thing, but I heard we would build something with CRDTs, and there is also part of this project was Kevin Jans, the creator of YJS, which is a JavaScript-based CRDT implementation. And this was fantastic, because we worked for a couple of months together, and was excellent to work with him. Like, really, really nice, awesome guy. Highly can recommend. And the fantastic thing is, like, I learned a lot about, like, CRDTs and pros and cons and so on and so on. so forth. So I was getting settled a bit into like, okay, I know what to do when working with CRDTs, and that was pretty nice. But and then I took basically the next step and decided like, okay, I actually gonna try to combine this with end-to-end encryption, and it took me a year. Like, I mean, I did it as a hobby on the side. Um, uh, Whenever I had a little bit of spare time, I basically started reading papers and reverse engineered the matrix protocol, tried to understand it. Initially, I tried to use the matrix protocol, which has end-to-end encryption with the OWN library. But yeah, I realized, okay, I have to go one level deeper, because it's a messaging protocol, and I actually want to have this concept of shared data. So I need full control over the protocol. And yeah, it took me a while to actually figure everything out. But after a year, or maybe a bit more, I had a prototype. I had something working. With a little couple more months polishing, I had a working document editor that works on Android, iOS, and also right now on macOS. Windows is also doable. It's not that hard actually. In this case, it's end-to-end encrypted. You have nodes, like basically simple documents that are end-to-end encrypted. You can collaborative edit it. And it would be real-time capable. Right now, I have an artificial delay of a couple of seconds because I didn't set up the infrastructure yet. But yeah, this is possible and coming. And one nice thing about it, like, because I focused on mobile and desktop devices, I could even make it offline first. So you could be completely offline. You could sit in an airplane with no connection. You can write the document for 1 hour, edit it, and someone else can edit it at the same time. And in the end, it will resolve to the same state. You will both end up with the same state, and conflicts will be resolved as good as the algorithm, the CRTT algorithm can do it. Yeah, for me, this was like mind blowing. I was super happy once I got to that point. And yeah, basically, I mean, what I haven't mentioned is like, I thought of myself as like, what do I do the next couple of years of my life? Like, can I do something impactful? And this was really something that I cared about. Like, basically, I wanted to have this, have the possibility to get control over my data again. And now I'm on this journey where I'm thinking of like how to expand this, and how to like, where does it make sense? And to show you a little demo, here we basically, on the left side, we have one device where someone already has a node, and she adds another collaborator to the node. They already verified previously we had a contact, and then the other person has access to the same node, and you can see how both of them edit the node. And basically, this is the data is going through the server, and everything is end-to-end encrypted. So the server has absolutely no idea what the content of this node is. And yeah, as I already mentioned, this is like, for me, this is just the beginning. There's so many more. Right now, it's still very simple, but there's like so much more is possible, like workspaces, full-fledged document editor, like resembling a lot of the Word features or Google Doc features. You can have a history, could have comments, and there's like basically almost everything that you can do without end-to-end encryption on documents would be possible. And even like in terms of privacy, things can improve. Because there's one gotcha. We talked a lot about end-to-end encryption, how it basically obfuscates the the content, but still, there's a lot of metadata. For example, for Serenity nodes, if you verify the contact, I know that, like, I don't know at this point, like, it depends if you add a payment information and so on. But basically, like, for most of the users, I have no idea who they are, but I still know that you and someone else are in contact with each other. They basically verify each other, and if you add someone to a node, the server also knows about this. They only know, like, okay, user 1 and user 2 share this node now, but you don't know anything about them. You don't know their names. You don't know how they store, like, the names they use for each other, and so on and so forth. Still, there's a lot of metadata, like how often you do an update. I mean, this is also metadata that we can delete. It's not done yet, but working on it. But there's, like, just the fact, like, that you share a node with X many people and so on is like, it's a lot of valuable metadata, and ideally this could also be removed. And this actually can be done, and I think this is where the future is so very bright in terms of privacy, because there's this concept of, or method, zero knowledge proof, and there's a very dry definition, and I'm gonna read it now. Zero knowledge proof is a method, this is the Wikipedia definition, by which one party, the prover, can prove the other party, the verifier, that they know a value X without conveying any information apart from the fact that they know the value X. And now, well, what does this mean? Like, how is this related to metadata? Well, for example, Signal already is using this for their groups. So what it means, a user can prove that she belongs to a group without the server persisting an unencrypted list of the group members. Meaning, like, if you get a database dump of the whole Signal database right now, I mean, they store, like, the groups and the relations, but everything is so encrypted in a way that if you get this database dump, you have no idea which user belongs to which group. But still, with zero knowledge proofs, if a user wants to add someone to a group, they can verify at this point that she or he actually belongs to that group. And this is super interesting and valuable, because we can actually, like, remove this part of, like, the implicit social craft that is being built from the actual database dump. And yeah, it's really fantastic. Which brings me to one more question, like, since the future is bright, should everything be end-to-end encrypted? Absolutely not. To me, yeah, this brings me. It always reminds me of the law of instrument, which, like, one. I mean, it had many authors, but one of them basically said, if you have a hammer, if all you have is a hammer, everything looks like a nail. And yeah, like, I don't know. Basically, first when I got the end-to-end encryption working and understood a lot more about it, yeah, I had this urge, like, everything should be end-to-end encrypted. But the more I thought about it, is, well, it doesn't make sense. I shouldn't use the hammer everywhere. There's a lot of, like, public data where it's valuable that this data is not end-to-end encrypted. I mean, think about open source code. Like, why should this ever be end-to-end encrypted? It's public information, and it should be. So yeah, the hammer doesn't always make sense, and we should not end-to-end encrypt everything. And yes, this is a video of me building a paper plane with a hammer. Which brings me back, what should we end-to-end encrypt? Well, if we look back at our scary slide with all the data, we could, it makes a lot of sense for a lot of data, like electronic health records, location data, documents, notes, spreadsheets are the obvious thing. We talked about it a lot. Like contacts. Why do service providers need to know all about like who you know, who you ever met, and when you added them as a contact? Your calendars, like it has a lot of information. Well, some information might be good to share publicly, so it's fine to make some information public, but it would be good to have to give people the choice, like what data should be end-to-end encrypted and what not. Or yeah, and how do we get there? Well, we need basically the industry is evolving and we're making a lot more progress anyway. This is very good, but at least what I'm trying to do, I want to simplify the tools. First I want to understand it. I want to build something with it. I want to basically focus on this, like making end-to-end encryption accessible and easy to handle, almost as easy as unencrypted data. And then people, I'm gonna build it myself as well in some parts, but I think people should be able to build a lot of end-to-end encrypted services way easier. Yeah, and apart from that, we just need a little bit more love for privacy. So if this was very interesting to you, let me know. Feel free to reach out if you have questions at nick@serenity.re. Please check out Serenity Notes if you're curious. And last but not least, if you're a very technical person, next Wednesday, I'm gonna give a talk on a security meetup of the Viennese security meetup, where I actually talk a lot about the technical details and how the encryption protocol is designed of Serenity Notes. I hope you enjoy.
Our next speaker is Kian, who is the founder and president of Nearform. Kian is an extremely passionate, pragmatic and funny person. For sure, very funny. You can spend a whole evening learning really weird things from Kian. Some of which in hindsight I wish I wouldn't have learned from him. But then on the other hand, it was a really funny evening. I think I met him the first time at NodeConf EU 2017 in Ireland, in Kilkenny, somewhere in the middle of nowhere, on a small village. He's running these events for I think 12 years now, which is a great opportunity for the Node community to come together and celebrate. He's also extremely passionate about open source, and the most recent success that he had with the company was launching the COVID tracking app for Ireland, where all of this is essentially built on top of Node.js and JavaScript, and all of this is open source. So please welcome Kian and enjoy the talk.
Hi everyone, welcome to my talk for WorkerConf. My talk today is breaking chains of transmission with JavaScript, and just like to thank the organizers for WorkerConf for putting on such a nice conference and asking me to do a talk. So I'll tell you a little bit about myself. My name is Cian O'Madine. I'm Irish. I'm living in Waterford, which is in the southeast of Ireland. I'm 42 years old. I live in a small little kind of seaside town. and I'm married, and I've got 3 kids, 1 girl and 2 boys. I founded Nearform, and also I started NodeConf EU a couple of years ago. So a little bit about Nearform. I started a company 9 years ago from a small town in the southeast of Ireland. Always really loved open source, always loved the internet and the web platform, and spent a lot of time on airplanes for the first few years, getting out there and getting people to know who we are and what we do. And as the company has grown and we've been really successful, we've grown to just about 200 people now. Everything we do is remote. We've people in about 20 countries, and we make our money by designing, building, operating primarily web and mobile platforms that live on the cloud. We're big contributors into the Node.js ecosystem. I think we were the biggest contributor for 3 or 4 years in a row there. We also contribute to the React ecosystem. We really love open source, and we think it's really important thing to be involved in. So anyway, the story, that's not why you're here. So we're here today to talk about how we created the most widely used exposure notification app in the world in 2020. And all the experiences that were involved in that happening. It was pretty amazing year. Yeah, I guess like the way it started, beginning of 2020. I went on a business trip to London at the end of January. On the way over, I felt my throat was getting a bit sore. I spent like 3 or 4 days in London, and progressively over the 3 or 4 days, I was kind of getting more unwell day on day. And when I arrived home to my family that weekend, I was like trying to make out like I felt okay, but I really wasn't. And so I got home on Friday night. On Saturday, I was really sick. On Sunday, I didn't want to do anything, but I had a fever. So I went to my doctor, and my doctor said to me that I had a chest infection and I had a really bad flu. And he gave me antibiotics and various things to take. And I went home, and I spent a week in bed where I felt really, really, really ill. And strangely enough, my wife also got sick the same week, and she went to her doctor, and her doctor said, you have a chest infection and you have a flu, and so on. And so in my week that I spent in bed, of course, I was on YouTube, and I was on all these news websites, and I was reading about this virus and all this stuff coming out of Wuhan in China. And of course, I was like going, there's a pandemic coming, and my wife was looking at me like I was crazy. She's like, yeah, right, go back to bed, pandemic, yeah, whatever. And so it took me about 4 or 5 weeks from getting sick that week to get any way back to normal again. Like, I tried to go back to work the next week, went back for 1 or 2 days, ended up back in bed again with a fever. And I honest to God, I don't think I've been that unwell ever in my life. And so about a month later, when they announced that there was a pandemic, my wife was, I was able to say, I told you so to my wife, and hopefully she's going to listen to me from now on when I tell her all these things, but probably not. So it was a very strange time. I mean, around March of 2020, if you remember back in the media, we had like all the terrible things happening in Italy. And everybody was really scared, nobody knew what was going on, and everybody felt pretty powerless. And in Ireland, like, things are pretty serious. They canceled the St. Patrick's Day festival parade, which is like, that's like Christmas in Ireland. So if they cancel that, it's like really serious. And so on the weekend of the 20th of March of 2020, I got a phone call, and it was somebody that worked for the Irish government, and they They were like, we've heard that you guys are really good at building applications, and you're the best the best in Ireland, and can you help us to build an app? And and it was somebody from the Department of Health in Ireland. They decided they wanted to build an app to help to detect the spread of the coronavirus using Bluetooth. And so I was like, of course I'll help if I can. And so this was a Sunday, and I called some of my team on Sunday night. Some of our designers started to pull together some designs and capture some requirements for an app, and we started working on the COVID tracker for the Irish government. And I suppose this is the story really of how we built it and what happened and all the experiences of working on COVID tracker. So to go into kind of some of the principles that we really discussed in those early weeks when we were looking at building this application to deal with coronavirus, we decided that at that time everyone felt very, very powerless, and that whatever we built would have to have some level of utility where we would empower people as much as we possibly could. So we wanted to put a daily health check-in into the app. We wanted a symptom tracker in the app. And we also wanted to put some information on what the infection rates were like in the locality that somebody is living in. And we felt this is really important, that the app had to have more than just like proximity alerts for exposures in it. We needed to put more functionality into it. We also realized that privacy was going to be really important. People really don't trust the mobile platforms and the technology platforms these days. So everything in the app would have to be privacy first, and any of the features on data sharing or everything would be really clearly labeled and optional. And then the trust and transparency would be hugely important in the process of building this piece of software. Because if people don't trust, something like this type of tool, nobody will adopt it, and you need like some level of numbers of users for it to be useful. And finally, then we knew we had to cater for people from very young age to older ages. So we were kind of designing from 15 to 85 years old. And so the journey started on the 22nd of March, and we went live eventually on July the 6th. And so here's some of the activities that we had to take part. First of all, we built an alpha version of the app by April the 1st. So approximately 10 days from that Sunday night, we had a fully working, COVID application. We to build our own custom Bluetooth implementation. We were testing this thing, and then later on in April, around the 20th of April, Google and Apple announced that they were going to release their own exposure notification API inside iOS and Android. And so we had to re-engineer everything, which wasn't a bad thing actually, because without the operating system level support for the exposure notification protocol, probably wasn't going to work. And so from there then, in May and June, we had to basically rebuild everything and test everything again. And we do a whole bunch of other things. So we had to cater for multiple languages inside the application. Initially, it was 2 languages, Gaelic and English. We'd carry out accelerated behavioral studies. So we really had to look at like what data were we going to graph inside the application? What was the messaging to people who are downloading it? Like things like, am I protecting myself by using the app, or am I protecting other people by using the app? And to test these messages and see what was going to resonate with people. And then, really importantly, we produced this data protection impact assessment, and that landed 3 weeks before the launch of the application. So this was like a human readable document that explained to everybody exactly what data was being shared and what wasn't inside the application. And then also we published the source code 3 weeks before launch, so people could download the source code, build it, see what's going on, it would like hit those objectives of trust and transparency for people. So here are some screenshots from the COVID tracker app. You can see the landing screen on the left-hand side. It gives you some like numbers around the daily check-ins, who's using the app. You've got like some of the sign-up screens inside in the app. Again, it's like everything is optional. And then some screens around contact tracing, how many people have used the app. And finally, then a close contact alert screen. And these are just like a couple of the screens from the app that we launched. And so eventually we got to this huge and exciting launch day, which was on the 6th of July. And you see on the screen there, this is the Health Minister for Ireland, looking all happy holding the app. And we launched the app, and it went really well. So it's interesting to see some of the tweets that day. First, data protection, really not bad. Data protection information notice is written in admirably plain English. Users can opt out a lot, and it doesn't access any of your files or camera or anything. Also, the code is built in React Native and TypeScript, and it's under MIT license. So this is really important for people to start to trust the app and trust what was going on in it. And then the app registration screen. So on the day of launch, we got to about 1 million users within 24 hours of the first launch. And everybody really just kind of decided to adopt it and start to use it. And had about 20 million API requests in the first 24 hours. So it was a lot of fun, it was nice to see the level of adoption in such a short space of time. So it was a huge success, the launch of the app in Ireland. Probably one of the proudest moments I've had as in my career, and being actually able to do something to help someone in their life and all that good stuff. And so where do we go from there? Well, we wanted to scale the application, and we knew that like once we'd solved the problem, that we really wanted to help as many countries as possible to adopt the technology. And so we focused on how could we help other governments to roll out this type of solution really, really quickly. So we took the approach of taking as much friction out of the process as possible, making everything as cookie cutter as possible, having like playbooks, run books, kind of recipe books really for success for how you do this. I think it's a huge case for open source in general. We were very lucky working with the HSE that they were open to open source. So they created like they actually created a GitHub repo as part of this project and put the source code up in GitHub. And the case for open source is really strong. Like, one country builds this, they test it. In Ireland, we had like the Irish Army testing the app, we had the police force testing the app, we had all these things, and the Department of Health had validated the app and all this kind of stuff. And so when you get the source code to the app, you're getting all that. You're getting all the work that's gone into it as well. And so, it made a lot of sense for others to adopt it rather than build something from scratch. The other thing we did is we really focused on, this was not about making money for us. So the cost per system after we did the original implementation, which was less than €1 million. I think it was about 800,000 euros. The cost per system thereafter was about 25% of this. So we really focused on, well, how can we help people quickly? We tried to get it down to like being able to do a deployment in a month. And one thing that's really interesting is that as we started to do more and more implementations, like each implementation had some various level of requirements, and they would contribute features back into the code base that would be useful to the other people that have been contributing in. So it's a real case study. In terms of app launches, we launched in all these countries last year. So Ireland, Scotland, Jersey, North of Ireland, Gibraltar, and then in the US, New York, Pennsylvania, New Jersey, and Delaware. And then at the end of the year, New Zealand actually were able to take the source code and deploy it themselves, because the level of investment was sufficient in the project at that stage that it was like easy to pick up and use. So some of the milestones in the project, we started on March 22nd. Can you build an app in your form? Yes, we can. We launched COVID Tracker on the 6th of July. On the 20th of July, we took the step with the Irish government to donate the source code to a new Linux Foundation project, which was important in the US context. We went live in the north of Ireland on the 31st of July, and Ireland and North of Ireland were the first two countries in the world to use an interoperable format and to share code, and then all the other launches happened thereafter. And so when we created the open source project, we wanted to put a little bit of green magic into it, because we are leprechauns and we're from Ireland. So we called it COVID Green, and it's green for Ireland, but it's also green for the map of the color of the map going back to a nice green color. And that was quite a proud moment to say the least, to make that happen. So some highlights of the project. So in Ireland, about 40% of the adult population used the COVID Tracker app. The app definitely saved lives, definitely helped reduce the number of people who died and got really sick, and really helped to break chains of transmission. And again, like I was saying there, very proud moment that Ireland and the north of Ireland were the first two countries in the world to have two systems interoperating. So you can download the North of Ireland COVID app, and you can come down over the border to the south of Ireland, and if you get an exposure notification while down south, it'll come back around when you're up north again, and vice versa. In summary, I think we were, nobody could have foreseen people could have foreseen a pandemic happening, but we'll be much more prepared when the next one happens, and there will be another one. The big learnings for me is infrastructure like COVID Green, these types of apps, they should be in the public domain, and open source is perfect for the public domain. And the really exciting thing is that this approach and this way of building something, open sourcing it, and then sharing it and helping others to roll it out has created this huge set of new connections in public health. So who would have thought at the end or the beginning of 2020 that the people working for the Irish Department of Health would be talking to people in Pennsylvania, and they would be sharing ideas and source code about how to build and deploy and solve these problems around exposure notifications with one another. And it's really powerful, to connect those people via open source. And I think a model for the future, a really exciting model for the future, is one where last year we connected 10 or 11 government organizations, and they've started to use the same piece of infrastructure, and they've started to contribute to the same piece of infrastructure as one another. I think maybe a model in the future is where we create bigger networks of these types of organizations, and where the big thing is people are the same everywhere that you go. Fundamentally, there are nuances and differences, but a lot of the technology that's needed in one country is going to be the same as another. So can we get to a place where we build these big networks of public health or public organizations, where one person in a network or one organization in a network builds something that's useful, and everybody else gets a benefit from it? And I think that hopefully is going to be the future for technology for public good. I hope my talk has been interesting, and it's been a pleasure to be able to present at this conference. And I'd like to thank the organizers. And if you have any questions or follow-ups, I'll be available on Discord after the talk and later on today. Thank you very much.
This guy is one of the reasons why the startup scene here in Vorarlberg is existent. Throughout his journey, it was all about bread. Sliced bread, sourdough bread, and now that bread. Welcome on stage, Jorok.
I'm excited to be at WorkerConf 2021. My name is Jorok Batlok, and I'm an entrepreneur that is working right now on a new climate tech startup. Previously, I've been engineering manager as CTO, but also an engineer, coder at the very beginning of my career. And I've been often asked about what is the most important success factor when building a company and also when working with a team. And to me, the answer is pretty simple. It's all about learning. It's constant learning from the very first baby steps you take until you do more advanced stuff. You're creating whatever crazy software. You have to start at the beginning. And that's what's called, also from a Japanese Aikido, the shu level, where you are protected, where you obey. Think about the fairy tales. Hansel and Gretel, they walk the path you've been told, you follow exactly the path, something good will happen. If you leave the path, maybe not so good stuff will happen. If the bread is in the oven and if it's ready to take, you should take it out. This is like the ethics, the operating system that you learn. I was thinking about how did I actually learn coding? Not just math in school, but the real stuff, things that you could not learn in school. It's like if you want to be ahead of your time, you need to learn stuff that you can't just learn in a traditional environment. And so the books you could buy, and you had software in there that you have type. You were just following exactly the path. It was the shoe. It was the exact thing, and you typed the code. And after that, you had your solitaire game. And to me, I think I learned most about coding and software engineering when I was part of the Zope and Clone community. And one of my greatest mentors was Zwark, Philip Auersberg, a legendary core developer of the Zope and Clone application server. I've been sitting for hours next to him and just watching his commits, watching how he codes, watching how he wrote the line, how he typed back, how he deleted it, how he refactored the code. And it was just by watching and by following him and also his exact instructions what to do. I remember my first software that I contributed was a registry for some content types you could do. And by line by line, he kind of told me exactly how to do. And at some point, I was a little bit more confident. I was able to detach a bit, to digress from the path. Think of Hansel and Gretel. At some point, they go through a small loop that is a shorter path through the forest, and it's still safe. And they're getting more efficient. They're learning. A very good example is also cooking. In the shoe level before, you just start with following a recipe. You take this amount of eggs, you take this amount of sugar, you take this temperature in the oven, you leave the cake in there for a couple of minutes, for exact amount of minutes, and you have a cake. It's magic. In the half phase, you start to separate from that. You start to do your own stuff. And if I think about back to Zwark, it was the first time when I actually started to modify some code that I learned from him, or that there was some of his programs where he maybe could be something improved. Pair programming is a really good thing where you are exploring, where you're taking a new path and someone is sitting next to you and giving you feedback. Or you have a sparring partner where you're not alone in this process. So I really encourage you to do these sessions. It's not just about some people tell, oh, it's inefficient if two engineers are coding at the same time. No, it's about learning. It's creating better software. think like in billiard. At some point, the first time you do it, you are happy if you can hold the cue, if you're happy you can hit the ball, but then you start to do a little bit variations, you start new moves. And the more and more you detach, the more and more you're confident, you're even going to a higher level. It's like you're separated from the thing. Think of the Dalai Lama. Dalai Lama is just there. You can feel his presence. He knows how to do things. And in coding, it's actually pretty similar. At some point, you're mastering it. You can build architectures. You can build more complex things. You don't need exact recipe. You have a vision of what you're going to build. You take some ingredients in cooking. You look in the fridge, you cook something. And in the Plone soap community, it was fabulous at these hackathons where all these people were together. And you had all levels. You had these masters, you had the juniors. And at some point, you were also at the position where you could give input to others. You knew how to code. But at some point, you were even at the point where you could give them more instructions, where you have a little bit like the wizard who could tell it. And that level, you can feel it or you know it. It's even more detached. It's called the kokoro. It's called the essence. It's the heart of what you do. So in this community, we had really blessed people. And if you follow their careers, they're now very high positions at Google. They've created amazing stuff at Mozilla. They did security stuff you cannot think of. But how did they do it? It was about them totally releasing and just being. It was like really these mornings after these coding sessions where we were rolling down the hills, our heads just empty, and we were just there and doing it. And to me, Phil, he was one of the people who could live it. He kind of totally detached from it. And coming back, how to grow people in the company is giving them the time, trust the process. The juniors, or even me as an expert level, if I learn something new, like I just recently did when I learned kite surfing, never did it in my life. I was just following the instructions. I did exactly as been told. I did not try to run a loop initially. I was just doing the initial steps as we spoke. And I was patient. It was just small piece by small piece. The second step is to detach, to digress, to start exploring, start making mistakes, and also get the feedback from these mistakes. So you remember the pair programming sessions come in at this point, and also other feedback things. This is also maybe not the most efficient thing, but still it's very important to learn. And don't forget, you should not stick at this level. You maybe should detach further, where you're coming to the master level and where you maybe need to leave the process at all at some points. Because process is, of course, helping you to some level. But at some level, you should break with the process, because otherwise you're stuck not at the optimum. And also you're maybe not making advances that are really needed. But at some point, also try even to go more into mastery and also help the people in the lower level to reach it. The kokoro level, the essence, the heart level. I think this is the most desirable state, because you're able to teach other people in the most efficient way. You know what the small shoe steps are. A kokoro master, someone who is living it as his heart, he can create the small steps that are needed for someone to start by just following the instructions. And this is also letting loose even more, where you start compared here in the agile methodologies. You just code. We had no process. We just were typing listings from a computer magazine. At some point, you did your first Scrum course. You did a certified Scrum Master, product owner, or whatnot, and you are experimenting with Kanban, Lean, extreme programming. But at some point, you can't even tell, you're just doing it, and you're creating stuff. But mastering the basics and reducing it to the max, leaving away all the stuff that is not necessary. This is the Kokoro step. And no matter what level you are, you're responsible for the people in the lower stages. And even someone is not just as a whole in a person in one state. It depends so much on the skill that you're learning. And if you're learning skills that cannot be learned somewhere in school or whatnot, really try to follow this path and also go up the ladder, but also let loose at the end of the ladder. Because if, like in fairy tales, we're always only following the path that we've been told, and we do exactly as we've been said. If we take out the bread, if it's ready, if you're taking the fruits, if they're ready, we're not getting anywhere. So that's why we should just fuck the bread, because the bread is over. It's about exploring new things. It's about letting loose, and it's also about helping others to advance. Thank you so much.
Have a break.
Hallo, ich bin der Yogi. Ihr kennt mich wahrscheinlich aus Serien wie zum Beispiel Prima Kochen mit der Yogi. Heute geht es so ums Kochen, ich habe aber keine grosse Lust. Also wird euch jeder jetzt sein, wenn den ganzen Tag am Computer daheim hockt und man programmieren. Heute geht es um schnelle Küche und zwar um Chili con Carne. Und zwar aus der Dose. Ich weiß, ihr habt das Gefühl, die Dose ist schlecht, aber wenn es ums Inkochen geht, hat die Dose die beste Ökobilanz als Einwegverpackung. Darum tun wir jetzt eine Dose auf. Heilige Maria, Mutter Gottes. Okay, tun wir also in einen Hafen. Ein kleiner Schluck Wasser. Tun wir das Wasser.
Entschuldigung, das war mein Einsatz, das Wasser.
Ja, gut. Dazu und aufkochen, okay? Und eine Minute lang richtig gut durcherhitzen. In der Zwischenzeit könnt ihr meinen YouTube-Kanal abonnieren oder mir auf Instagram folgen. Okay, das Chili ist fertig. Aber er hat ja etwas für ein 4-Sekunden-Video gezahlt. Darum sage ich, was in der Dose alles drin ist. Was sind drin? Zwiebeln, Karotten, Sellerie in Bio-Qualität. Dosentomaten von aus Italien in Bio-Qualität. Darf ich die Marke nicht mehr eigentlich sagen?
Ja, passt schon.
Okay, es sind steirische Käferbohnen drin. Vom Naturhof. Es sind Bio-Gewürze drin von der Firma Pfeffer, Paprika, Kurkuma, Ingwer, Cayennepfeffer, Zimt. Es ist Schokolade drin, Schokolade. Also ist ein Ursalz drin. Also ist dunkles Bier von der Brauerei drin. Und natürlich auch Rindfleisch drin. Fleisch ist jetzt ganz etwas Wichtiges. Ich wasche, vorüber nicht ein lustiger Social Media Clown. Aber eigentlich geht es mir um etwas anderes. Auch weg vom Industriefleisch. Wieder zurück zu klein strukturierten Wirtschaftsabläufen. Nur Gras und Heufütterung beim Rindfleisch. Kein Kraftfutter. Nur Gras und Heu vom eigenen Hof. Das sind die Punkte, wo wir wieder annehmen müssen. Die Message ist, erst wenig Fleisch, aber wenn, erst mit Hintergrund. Und das alles kriege ich bei ausgewählten Bauern im Bregenzer Wald, mit denen wir natürlich gut verstanden und die natürlich auch mit den Tieren so umgehen, wie man das vorstellt. Das Fleisch wird bei mir daheim beschaffen und im Hinblick auf Reifung und Lagerung sorgsam behandelt. In dem Chili zum Beispiel ist ein gutes Hackfleisch drin, das wird aus dem Lemper und aus dem Hals gemacht, aber es wird alles vom Tier verschafft. Angefangen vom Knöchel über die Innereien, also Innereien mache ich zum Beispiel ein Bäuschel, über die Schulterbräute und ein Gulasch aus dem Watschenkel bis zu den edelsten Steaks aus dem Englischen. Alles wird verschafft, ein Tier nach diesem. Und natürlich lasse ich dich als Vegi oder sogar Veganer auch jetzt gelten. Darum ist für dich in deinem Säckchen ein veganes Chili ohne Carne drin. Wie sind wir eigentlich in der Zeit? Okay, dann sagen wir geschwind, dass wir dazu machen können zu dem Chili. Das Einfachste ist, wir machen den Reis dazu. Im Reis mitgekocht haben wir mit Nelke gespickte Zwiebeln. Das heißt Chili drauf, ein Klecks Sauerrahm und eine Gremolata. Das sind einfach frische Kräuter, gehackt mit Zitronenabrieb. Und wer mag, kann ganz geschädlich-mäßig Nüsse hacken, kurz anrösten und drüber umströmen. So lange das Chili für 2 Personen.
Cool, okay.
Oder wir machen dann Wrap. Zudem tun wir ein paar Sachen vorbereiten, dass wir nachher ins Zimmer stellen können. Wir fangen an mit Zucchini. Gemüsehobel. Zucchini feinblättig schneiden. Okay. Schneiden wir da schon eine Julienne. Julienne nenne ich es. Okay, das sind so Streifen. Okay. Radiesle. Ganz, ganz fein hacken. So fein halt, wie ein Messer das zulässt. Hier ist jetzt so eine halbe Sante. Okay, jetzt kommt das mehr. Wir machen eine Blitzfermentation. Wir tun unser Gemüse in Schäle rein, tun ganz ein bisschen Salz drauf und lassen das Gemüse Wasser ziehen. Zu dem Salz ein bisschen einmassieren. Und für den guten Geschmack tun wir einen Schuss gutes Olivenöl dazu. Da haben wir einen Wrap, der machen wir uns jetzt genau die Hose in der Pfanne. Noch ein Flip. Der Tortilla ist heiß, das Chili ist auch heiß. Wir richten es an. Ein bisschen Chili. Dann unsere fancy Gemüse. Ein bisschen Rucola. Und ein bisschen Schaufkäse rundet uns das Ganze ab mit der Säure. Okay, stramme Nudel. So stramm, als es halt geht. Und gleich das Backpapier einschlagen. Nochmal jetzt. Nehmen wir ein bisschen Alufolie, wickeln das Ganze nochmal in, dann richten wir an. Wenn wir ganz cool sind, tun wir ein paar Chips unter der Bahn, dass es geil ausschaut. Okay. Den Wrap schneiden wir einfach quer durch und richten uns das geil an. Okay? Heilige Maria, Mutter Gottes, schau mal das an hier. Hey. Oder, wenn ihr einmal katzenblau sind, machen wir Chili Cheese Fries, okay? Voll easy. Wir nehmen ein paar Grümpel, schälen. Derweil machen wir uns am besten schon das Fett aus. Wir verwenden da reines Rinderfett. Das könnt ihr bei mir auch kaufen. Okay. Grumpeln. Wir schneiden so 5 mm, okay? Okay, wir haben Grumpeln fein geschnitten. Jetzt tun wir jetzt portionsweise frittieren, okay? Schön knusprig ausbacken. Nicht zu viel über einmal, bloß eine Handvoll. Inzwischen machen wir unsere Käsemischung. Wir holen Käse aus dem Kühlschrank. Und zwar verwenden wir ein Stück Bergkäse für den Geschmack und ein Stückchen Emmentaler, das ist eine schöne Fäden zieht. Mit der Käsereibe, den Käsereiben. Wir haben unsere Pommes schön ausfrittiert. Jetzt tun wir etwas salzen. Dann brauchen wir einen Teller. Pommes zuerst. Dann das heiße Chili drauf. Und ein bisschen Käse. Okay, das tun wir jetzt schön überbacken. Das Rot tut leider nicht. An der Stelle noch ein herzliches Dankeschön an Küchensponsor Blum. Vielen, vielen Dank. Ich habe eine andere Idee. Schnitzel. Für die, die es ein bisschen mehr mit Fuß mögen, tun wir ein bisschen einfach ein paar Chiliflocken drauf, okay? Oder wir machen uns eine Penne Bolognese mit einem Insalata Fagioli, okay? Zu denen nehmen wir uns hier die Bohnen raus. Jetzt kochen wir so ein paar Nudeln, machen das Chili nochmal heiß und dann richten wir an. Die fertigen Nudeln tun wir zur Bolle dazu und auf den Teller. Dann nehmen wir unsere sauber getrennten Bohnen. Tun wir einfach mit Essig und Öl marinieren. Fertig. Und wenn du mich aber fragst, Yogi, wie kriege ich eigentlich das Chili auf, wenn ich die Dose öffne? Dann ist das meine Antwort. Ein originaler der Yogi Doseöffner. Die ersten 10 Kundschaften, die mir in den Laden kommen, kriegen so einen Doseöffner gratis zum Einkauf dazu.
Our first speaker after lunch is Max. Max is known from Style Components, React Boilerplate, Spectrum Chat, or speaking at WorkerConf. I'm always thinking about my own product. And in that time, Max releases another one. Last week, he successfully launched Graph CDN. Now listen to him and enjoy his talk.
Hey, my name is Max Stoiber, and I am super excited to be here today and talk about how I answered one of maybe life's hardest questions, which is, what do I want to do with it? What do I want to spend my life doing? To give you a little bit of context of where the situation came from and why I asked myself this question, apart from general existential dread after pandemic and stuff, we'll take that into account. But of course, there's a lot of context to this question that I have to talk about first before I can tell you about how I approached it. I want to start my story from Spectrum. Back in 2017, at the beginning of 2017, I co-founded a startup with two of my friends from San Francisco, Brian Lovin and Bryn Jackson. And we built Spectrum, which was this community platform, basically. It was like a modern forum in very simple terms. We, of course, had more fancy terms, but really it was a more modern forum for communities to hang out in. And Spectrum went quite well. We built that for 1.5 years. But also, whenever you found something yourself, it's sort of a lot of up and down. And if I were to chart what it felt like to me to found Spectrum, it would look something like this. Very wavy, definitely some red parts that were less great, but also a lot of green spikes where things went really well. The way I describe what it feels like to found a startup to my friends who don't work in the tech industry and have no idea what that even means is I say it's sort of like surfing a little bit. You're in the water trying to catch a wave. You're trying to get that initial traction. You're trying to get the first people to use the thing you think is great. And it takes a while and you're just like paddling around waiting for the swell to come, and then eventually it comes. And you start paddling, and the wave picks you up and brings you along, and suddenly you're on top of your surfboard and you're surfing and you're feeling fantastic. Everything is going super well. You're up there, you're doing your thing, you're in the flow, everything's going super well. And then suddenly the wave comes and sweeps you over, and it just smashes you face down right into the ocean. You are under the water, you can barely catch your breath, you feel like you're kind of dying. There's water everywhere. You're trying your best to orient yourself. Where the hell are we even? How do I get out of here? I want to get out of this water. I want to breathe again. And then you get back out. You sort of take a step back. You relax a little bit. You take a deep breath. Find your surfboard and you paddle back out and do the whole thing again. Now, described like that, either that sounds terrible to you or that sounds great to you, right? Depending on if you enjoy surfing or not. But I think emotionally, that's really what it feels like to found a startup. It is these constant waves of up and downs, and the highs are very high, but the lows can be very, very low. And that's just the way startups go, right? Nothing that you're ever going to found is going to be a straight line up and to the right. That just doesn't exist, right? It's always these waves. And a lot of what I learned during that time is how to manage these waves, because in reality, they are what kills startups, right? One little downturn, one little low can really break your spirits, and it can really break your momentum, and that basically kills you. And that can happen very quickly in startups. If you have a bad time, like we had in the middle there, in the red area, I made that red because we had a memory leak in our backend servers, and our servers would crash at the beginning once every day, but because of our growth, it eventually became once every hour. And I was the main technical person at Spectrum, and I couldn't figure out why the memory leaks were happening. And it was a really bad time for me because I was just constantly under stress to figure out this huge issue that we were having and I just couldn't. I didn't know what the solution was, and it took me 2 months to figure out the solution and finally solve the problem, and then everything went well again. Now, overall, the 1.5 or 2 years that we built Spectrum, I would say overall they were an 11 out of 10 experience. Yes, there were a lot of up and downs, and it was sort of an emotional challenge to manage them, but I was also the happiest I've ever been. I'd never been that in charge of my own destiny before, and that comes with a lot of responsibility. That comes with a lot of pressure to do the right thing and to succeed, because if I don't do it, nobody else is going to do it for me. But I love that. And I really enjoyed founding Spectrum. Eventually, GitHub acquired Spectrum. And Bryn, Brian, and I, we were still just the three of us. We joined GitHub to integrate what Spectrum was, essentially a modern forum, into GitHub. Now, if I were to chart what it felt like to work at GitHub, it would look something like this. As you can tell, there isn't a lot of red, which is good, but there also isn't a lot of green, which is not so good. Working at GitHub for me personally was fine, right? It was a nice job. The people there are great. I had a great team. I had great coworkers. I had a fantastic manager. I was working on stuff I was relatively passionate about. I had a lot of flexibility in my life. I was paid well. I could build something for hundreds of millions of developers, but still it was fine because I didn't feel like I owned anything. Like whatever I did didn't meaningfully contribute to GitHub's success, right? GitHub is a success. I can neither influence that and make it more of a success, really, nor can I destroy that success. So there isn't any responsibility, but it was still a fun experience to work there, because working on something that I use every single day is really cool and something that I cherished a lot. Overall, I would say working at GitHub was sort of like a 5 out of 10 experience. It was fine. It wasn't bad. Like, there weren't any very bad parts, but it also wasn't great. It wasn't what I wanted to do with my life. And so after again another 1.5 years or so of GitHub, I said, meh, this is kind of just fine. Like, I would rather do something else. And found, just by pure chance, a new job at a startup again called Gatsby. If you're in the React ecosystem, you might know Gatsby as the static site generator. And I joined Gatsby to work on a bunch of R&D projects. And for a little while there, life was great again. I was at a startup again. I had a lot of responsibility on my shoulders. I was still working with a great team, and there weren't like any existential troubles, like we weren't gonna die at any moment. And I was working on cool stuff. I really like Gatsby as a framework. I really like Gatsby. The people that I worked with there, my coworkers, were fantastic. And then after a year there, I looked at sort of reflected on what it felt like to work there, and came up with a graph that looks something like this. This looks remarkably similar to the GitHub one, right? Nothing particularly terrible, like there's no red parts, there's nothing that's really, really bad, but also not a lot of green parts, right? Not a lot of these really high highs. It was just fine again. And I would say, on balance, it was slightly more enjoyable to me than working at GitHub, because I had more influence and more responsibility. And it was just a young startup and there was a lot to do. But it was still fine, you know. It was a 6 out of 10. It was a slight improvement, I would say, but it still wasn't really what made me happy. And it was just fine. And really after a year was like, okay, this is fine, but how do I get back to an 11 out of 10 experience? How do I get back to that state of real contentment with what I'm doing every single day? Really, what do I want in life? How do I even figure this out, right? Like, how do I even figure out what the hell I want in life? And so I went to my coach and I discussed it with him. I said, hey, look, this isn't it. Like, how can I figure out what I want? And he basically told me that I should ask myself the question, what do I actually value? Now, the next slide is not one that I ever thought I would share publicly. At the time when my coach asked me this, I sat down and I had a really, really honest conversation with myself about what do I actually value, but also what do I not value? What do I care about? And what do I really not care about? And it was extremely difficult because it required being very honest with myself, despite sort of social pressure to say or do certain things. And you'll know what I mean. Now, again, I did not expect to share this note publicly. This is literally the note I wrote at the time based on just sitting there and thinking about what do I value. It's written by me, for me, and it's very rough. So don't expect this to make a lot of sense for you or your situation. This is very personal to me. But I realized I have to share this because otherwise this whole presentation doesn't make any sense because you're not going to understand why I made the choice that I made. So without further ado, here is the list of things I value and the list of things that I don't value. What I realized I really value is connection, responsibility, agency, variety, openness, and prestige. And the things I realized I really don't care about, even though I maybe should, are money and impact. Now, some of these were easier to admit to myself. Some of these were a lot harder to admit to myself. Specifically, the fact that I don't care about impact was pretty hard to admit because impact is very much what you're judged on when you work in a big company. For example, at GitHub and at Gatsby both, the entire promotion process was based on the fact of your impact on the company. And that can be impact to as many people as possible or the biggest impact, however you want to frame that. But it's very much about impact. But when I think about it, I wasn't any happier when I was doing something for 100 billion developers at GitHub than I was making something for a couple hundred users at Spectrum, right? I didn't care about the scale of the impact. I didn't care about sort of how many people does this touch. I cared about, does this make anybody's lives better? And at that point, even if it's just one person, I'm content with what I'm doing, right? Particularly if it's my own, like if I have the problem myself, that's the best because then immediately there's at least one person that wants the solution to this problem. And so I don't personally really care about impact. That was hard to admit because it's sort of like maybe, I don't want to say a red flag, but it's something that you have to care about if you want to succeed in corporations. And the fact that I value prestige was also very hard for me to admit to myself. I guess from the outside, it might be sort of obvious. I have way too many Twitter followers, way more than I'm willing to admit. And a large part of the reason of that is that I like prestige. I like being prestigious. I like being known. I like people respecting me. Even though it sounds vain and superficial, it's just the way it is. And that was kind of hard to admit for me as well. I was like, okay, I guess that's the case. And then the others, I love connection. I love people. I love talking to people. I love my family. I love my friends. I love having a lot of responsibility and weight off my shoulders, but also the agency to do something about it, the freedom to do something about it. I love a lot of variety. I don't like doing just one thing. I want to do a variety of different things in my days. Like I can't spend every single day doing the exact same thing. I want some variety. And I love openness. I love being transparent with people. I love sharing my thoughts. I love sharing my story. I love sharing what I do, which kind of comes with the prestige, but also I love working in public, right? I love doing open source. I love those sort of things. And when I looked at that list, I took that list and I thought, okay, sort of, I guess my two main options here are either I find another job at a big or small company, or I go found another startup, right? Those are sort of the two main options I'm considering. Like, how do those two options cover that list? How do they apply to that list? And when I looked at it, taking a job sort of covers some of these things that I care about, and a lot of the things that I don't care about. So a job, agency at a job is not really a given. Like when you work at a big company or even when you work at a smaller company, you don't really have that much choice to do that many different things. You can't just decide, oh, today I feel like doing marketing, because you're going to be stepping on the marketing team's toes, right? And they're going to feel like you're trying to do their job and you're sort of restricted to your lane. I'm an engineer, so I got to do engineering, and everything else is sort of outside of my power, and other people do that. In terms of openness, there's zero of that in most cases. Gatsby is the exception there, but In usual corporations, you really have no way to be open with the public about what you're doing. And then responsibility, you can have some, but it's not like, yes, you can be responsible for some people as a manager, for example, but you're not really responsible for the success of the company. Like at GitHub, whatever I did wasn't gonna meaningfully change the trajectory of GitHub. Maybe a little bit, but not. It's not gonna make or break GitHub. Basically, my responsibility wasn't at that level. And then variety, again, you have to do your job. You can't just do what you feel like. Now compare that to founding a startup, and I realized very quickly that actually covers all of the things I care about. And while it doesn't cover the things that I don't care about as well, money and impact, I don't really care about them, right? A startup gives me a lot of connection with my co-founders, but also with my users, potential customers. There's a lot of responsibility, obviously. If I fuck up, nothing happens. If I don't do anything, nothing happens. If I do something wrong, it's wrong. There's a lot of agency. I can do what I feel like is the most important thing to do right now. There's a lot of variety. I have to do everything. And I can be as open and as prestigious as I want. And so it became clear to me that actually I probably want to found another startup, because that's probably what's going to make me the most happy. I also talked a lot with friends, and I realized that through talking to them, particularly my friends who are not in the tech industry, that I'm in the 0.1%. Now, that sounds kind of stupid, but if you think about it, there's 9 billion people on the planet, give or take. How many people of those actually have the privilege and the ability combined to found a tech startup? Maybe 10 million of those. That seems pretty like a reasonable assumption to me. 10 million is already a lot, but that's still only 0.1% of the entire planet, right? And I realized I am in that group. I have the privilege. I grew up in the West. I come from compared to sort of the average of the world, a very wealthy background. I have enough money to survive every single day, and I can take the time to build something new from scratch. And I am in that 0.1%. Now, the other side of the coin is, what does it mean to fail, right? If I were to go and found another startup, what does it mean to fail? Think about, Spectrum, in some sense, failed as a startup. We didn't manage to make any money, so we had to be acquired by GitHub. But even though Spectrum failed as a company, it really didn't fail to me, right? Because every single day I did what I love. And yes, there were ups and downs. There's always in life, there's always waves, there's always highs, and there's always lows. But overall, every single day I got up and I had a purpose in life, and I enjoyed doing what I did, and I enjoyed my life every single day. And I realized founding another startup means I cannot fail, even if the company goes nowhere, even if nobody cares about what I build or co-found, even if nobody wants it. As long as I enjoy my time doing it, it's all worth it, right? The old stupid saying, you only live once, YOLO. It's stupid, but it's true. You do only live once. And so I realized, why would I spend my time doing something that I don't enjoy as much when I have the privilege and the freedom to do what I really enjoy? And so I said, you know what? I'm going to found another startup. Which of course immediately led to the next question. What do I found and with whom? And to try and figure that out, I wrote this sort of like blog post about some of the problems I see in our industry and how they could maybe be solved. But none of them really resonated with people, and they didn't really resonate with me either. Like, yeah, the problems I have, but I wasn't passionate enough to really sit down and solve any of them. But then, remember when I said I talked with my friends about this whole thing about what I want to do and whether I want to found a startup? Well, one of my friends, Andreas Klinger, introduced me to a friend of his, Tim Suchanen. He showed me, hey, Tim has built this prototype for a GraphQL CDN, and I think it's really cool. Tim currently still has a job, but he might want to found this. Why don't you talk with him? And I talked with Tim and I was like, wow, he had built this prototype of a GraphQL specific CDN. So a sort of a bunch of data centers all around the world that can cache GraphQL queries at the edge. And so they're super fast for all the users, and it reduces a bunch of the traffic on the origin server. And the thing is, we actually had that exact problem at Spectrum. We were using GraphQL at Spectrum, and we could barely keep up with our traffic. Remember when I talked about the memory leaks? And this specific thing would have solved a lot of our problems, but it just didn't exist. And we couldn't just go and buy it because it literally didn't exist. And so I was like, wow, this is awesome. Hey, Tim, we had a chat. We hit it off almost immediately. And I very quickly bought tickets to go to Berlin and then hang out with him for a week. And so I flew to Berlin, slept on his couch in his apartment, and we just talked for an entire week, right? About, again, what sort of the same things I just talked about today. What do we value in life each? Where do we come from? What's our background? What's our story? Really getting to know each other very tightly. Because if you were going to co-found something, that would mean spending a lot of time together. And so we wanted to make sure that we're very aligned on the important things that we were going to do. And as it turns out, after a week, we were like, this is great. We're very aligned on our core values. We're very aligned on where we want to go, on our ambitions. And we both really love solving this problem. We love GraphQL, but we know there's trouble when running it in production, and we want to help people make that easier. And so we decided to co-found GraphCDN. Now, let me give you a quick demo of GraphCDN. This is what GraphCDN, the dashboard, looks like. Here I have created a service for the GitHub GraphQL API, and I'm fetching a repository called Cycle.js Counter. Now, this is a cache miss, and the GitHub GraphQL API took about 600 milliseconds to send us that data. Now it's cached at the GraphCDN edge, and no matter how often I query that data, it'll always be served from the GraphCDN edge. In this case, because I'm in Berlin, in about 70 milliseconds. In Vienna, it's about 30 milliseconds. It depends on your distance to our nearest data center. Now, the really cool part about GraphCDN is the purging. When I now run an update repository mutation and put in a new description for this repository, just something that's slightly different, a simple counter in Cycle.js, and I run that mutation, GraphCDN sees that this repository has changed and updates and purges any query globally that contains that repository. And what you can see now is this was a cache miss, and that means it went back to the GitHub servers, the GitHub API, and loaded the new data and got the fresh description and cached it again at the edge. And so that means GraphCDN can actually cache a lot more APIs than any other API caching layer can do, because we're very tightly aware of when data changes and can very efficiently invalidate any cached query results that contain that stale data, which is really cool. So to sort of summarize how I decided what I want to do with my life, I got an outside perspective from people that know me well, that I spent a lot of time with. I had a difficult but honest conversation with myself about what I really deeply value in life based on historic data, not just what I think I should value in life, but really when I look at my life, what does it look like I really value? And really a little bit of YOLO, you know, a little bit of, look, I'm only gonna do this whole thing once. I might as well spend it doing something that I really enjoy. And so what I decided to do with my life is GraphCDN. If you have a GraphQL API and you have performance problems, either because your server gets too much traffic or because you want your users to have a way faster user experience, come and talk to me. And I hope this gave you a little bit of inspiration for your own life and how you can approach figuring out what you want to do with your life. I'm Max. Thank you so much for listening. I hope you.
So when I started cycling, the guy who sold me my first bike said, don't do that here. You have beautiful mountains, but they're just too steep. And I think that's a perfect metaphor for starting something here in Vorarlberg. It's everything is there, but actually doing it is really tough and hard. The guy who can tell you everything about that knows everything about blockchain. But not only that,
With his recent project, he also knows everything about the chain and queue around your block in the city near you. Welcome on stage, Christoph.
Hello everyone, nice to be on the show. Thanks for inviting me to the WorkerConf this year, 2021. I'm really looking forward to the conference, and here is my talk about unstoppable websites with Sire and Handshake. A bit about me. I'm a software developer building websites for the last 24 years. When I started first, I was, I think, 15. That's my first project. It feels like where we are right now in the blockchain space. It's just like a few years to go, but we are building the building blocks to really create a decentralized world. And I'm really enthusiastic about it and hope that we can solve some problems we have right now. A bit about myself. I'm working on a product called City Monitor. It's a software as a service platform for municipalities to help them to be more sustainable, get more insights into their resources and how they work with their resources, and to improve their communication to the citizens. About myself, I'm a snowboarder and a mountain biker, so I hope I can get some kilometers and some altitude in for tomorrow's challenge. And on Twitter you can reach me as Cork, and yeah, my name is Christoph Glocke. So the current state of the web is a bit, I think it's going the wrong direction. We have some really big players in the space. So we have Alibaba, Google, Amazon, Azure, Tencent, you name it, all the big ones. They're building this cloud computing infrastructure, which is really powerful, which I am building and still building on, and has, of course, some advantages. You can just use the resources. But in the end, it's just like we are just dependent on these huge players, and we saw that comes with some advantages, disadvantages. So we're just we are in the hands of some big players, like on the infrastructure side. And if we look at the product side, if we look here, we see like Mark Zuckerberg, he can delete any post I publish because he wants to. If it's the reason they call it fake news or not, who cares? Amazon, like if we're using the Kindle infrastructure, they can just delete any books that's out there, and it doesn't happen. And we are living in Fahrenheit 451. On YouTube, they can delete the YouTube videos. They can delete your platforms from their indexes. It's just, I mean, you can call it right or wrong. I mean, it's always like a personal and individual view. Like even when they suspended Donald Trump's Twitter account, is it against freedom of speech or not? Like there are cases on YouTube, people talking about cryptocurrency in the blockchain space, and they just removed it from the index. Even if you look at China, which is usually the case, that people reference to China where they have these locked borders, they're just censoring keywords of cryptocurrency exchanges and all other kind of things. But you don't have to look to China. It's happening all over the world. So there is this kind of danger that tech companies start censoring for whatever reason they want. If it's right or not, that's, as said, it's subjective. So is it in danger? Like even in Germany we have this talks about Telegram, the messenger. Is he dangerous or not? Because people starting having groups on there. Of course we can say it's bad that people talk about conspiracy theories, but is then the technology bad? Is the information bad? Are the people bad? Like, if you think about money, like people saying like Bitcoin is bad because bad things happening with Bitcoin, but aren't bad things happening with any fiat currency like euro, dollars? Anything's bad. So are we in the danger of freedom of speech? So what should we do? Can we live with that? Can we just work with that? We're going to more and more centralized spaces. We're building on centralized spaces. It's easy to block centralized spaces. So just we block all the IPs that Amazon has, all the IPs that Google has, and then everything is done. So what can we do about that? Can we work moving into a place where we can't easily be censored? Freedom of speech is there. Move power back from the corporations? Yes, I think so. One more example is like what's the bad things about centralizations? I think everyone knows over the last few years, Amazon Center in Ireland was down. We couldn't access Netflix, Reddit, Spotify, anything. We just had like a Fastly case where someone, if it's true or not, just had a wrong configuration on there that has too much power, and like all the websites went down, the big ones that use Fastly. So if that can happen, and we already know about the Snowden, what Snowden brought up, that you can just click and have all the backdoors in there. So I think we should think about moving into a decentralized world just to give the power back to the people, to us, to the builders. So there's hope out there, because a few of us, we are fighting to create a decentralized world, and we are fighting for the freedom of speech and trying to take back the power from the corporations to the people. So we all talk about blockchain, you know, most people think blockchain is a hype word, blockchain, Bitcoin, mixing everything together. I think what we see now is like a really good case what blockchain can help us to achieve and how blockchain is used in there just to make this all possible. What's not possible, yeah. But I don't go into blockchain itself, but it's just a good use case because it's built up on blockchain. So what we're looking at is the Sire blockchain. So Sire is like started out from a few MIT students in 2014. So it has like some few years on its shoulders, and it's really growing really fast now. It's a typical hockey stick. They've built now the infrastructure. So what it is Sire is a blockchain that allows you to run a node and share your space that you have, excess space. Like if you have some terabytes left in your NAS, you can just start up a Sire node and rent that out. So the Sire blockchain runs on the Sire coins, and you get paid for the Sire coins, or you can even put your files out there, like your photos and pictures, and you're not dependent anymore on a centralized service like Google Photos or Apple Photos, whatever it's called there. And I see all the dots here. There's like one of the dots is my NAS that I'm running at home, and everything is encrypted. So like if you upload a file to the Sire blockchain, it's typically, and you can set that individually, but it's by default it's like redundant, split up into parts, and it's distributed all over the world, and 3-time redundant and totally encrypted. And yes, as I said, like it's paid with the Sire coins. So like if I upload a file, I have no idea where it's gonna end up, but I just know it's there and it's safe. If you see like the capacity is already 3.2 petabytes. There are 514 storage providers with kind of multiple nodes. So, and the used storage is already 1 petabyte. So it's really growing over the last years, especially the last months, because they're building up the new thing. So what you're talking about is like hosting our websites on the Sire blockchain. So like, as I mentioned, anyone can run a node on a decent Synology or QNAP NAS or whatever, like put a Raspberry on there, plug it in. You need a bit of RAM, but then you're just starting renting out your space you have and be one of the infrastructure endpoints of the world. What they came up with is like Saya was the blockchain just to build up file storing, and the Saya guys started working on what's the next step is Skynet, and Skynet is the decentralized web hosting. So it's a web portal built on Saya, it's built in Saya, and if you run a node, it's running the portal as well. And anyone can, you have to start it separately, but anyone can host such portals. And I can use Skynet, I can use my own Vidanova portal and build it up or whatever. There are a few portals out there, and if I upload a file on one portal, it gets pinned. So pinning is called like it's someone pays for it, so this portal pays for it, so, and it's out there and I can access it, and it doesn't matter if it's accessed on the Skynet portal or my own portal or whatever portal, it's just going to be there, and as long as someone pins it, it won't get deleted from the Saya blockchain. So that's really a nice and easy thing. So I even copied from the website how easy it is, as I guess most of you are developers, to upload, implement with the Skynet SDK, JavaScript SDK, upload, download code to use that. And I was really impressed when I first tried it out, and I even improved it a lot. So I uploaded the video, and it got download speeds up to I think 800k, and they say talking about 1 gigabit per second. So it's really fast, even if you don't know if it's on someone's NAS. So they did a really good thing there. The next step is, so like one of the file hosting, what we need is like a decentralized top level domain registrar, and that's another project I want to introduce. That's called Handshake. The company is called Namebase, so Namebase.io is running that. The blockchain is called Handshake. So the difference with typical DNS names, domain name, top level domain names, you have to apply for it. That like only the ICANN can really define what kind of domain types. If there's a new domain type, Berlin, you have to apply for it and stuff. So it's centralized, and in the end you're just leasing the ownership, because you need someone like GoDaddy and buy it there, and you pay the annual fees. And yeah, it depends on the authorities. So in the end, if I have a AT domain, I'm dependent on Internic, that's who's like issuing the Austrian domains, that it's allowed, and they just don't revoke it at any time. It's not really privacy. Like I can be like I can be hidden, but like with the whois, I can be looked up, which some people might not like to have, and yeah, it's easily seized again if you don't like it. So Handshake is different. So they are building an infrastructure that you have an own blockchain, and you just simply purchase whatever name you want. So like I could purchase Christoph Glocker as a top level domain and build my home.christophglocker. That's a full ownership. It's blockchain based. I can sell it to anyone else. It's just a marketplace at the moment. It's through Namebase.io, and so you have to purchase that. And you can even have emoji domains. What's pretty cool. Everyone likes emojis. So it's totally trustless. It's a community-driven project. It's I think they have a DAO behind it. It's totally anonymous. I can purchase it. I can sell it. In the end, it's totally censorship resistant, but it has still some drawbacks. But we get there as well. So here's some examples what I could register for. So .Christoph Glocke or .worker for the conference, .fuba. And as I was a bit late to register my domain for this talk, and it's still because it's a process. Like you can purchase one, then at the bidding phase, someone can bid higher, and then it's in the real, and my one is still in the real. So I bought yesterday in a Bartholomeberg for this talk and set that up. So Bartholomeberg is a small village here. In a Bartholomeberg is, I guess, I don't know, it doesn't really exist. But someone, I guess, might be listening to this talk, will be happy that I purchased the domain from him. A bit of a problem right now, as mentioned, when I started 24 years back and was still working with the Netscape Navigator, I think there wasn't even Internet Explorer around. So we are in the early stages. So not all handshake, not all browser support is yet. Actually, no browser support. The handshake DNS out of the box, except the Puma browser, which is available on the iPhone, iOS, and on Android. But you can work around. You set up your DNS to this IP, a few other IPs. You can read about that on HDNS.io, and then it resolves. Then it uses this DNS provider, also a community-driven project from the Handshake guys, and it resolves to your top-level domain. They also have like HDNS.2, a redirection where you can use the old system, and it redirects to the page you have. So if we plug it together, like we have now the SIA blockchain and the Handshake domain system, and SIA Skynet for hosting the files, and the DNS names for resolving the files. So we are now that's kind of part of the building blocks for decentralized worlds, which I'm gonna list up a little bit here. Of course, there are about 100 projects out there that trying to achieve different things. But I just want to give you a big quick overview where we should go and where it's gonna happen and what kind of project there are. So like in a few years, everyone is gonna have a decentralized IDs, not just your governmental ID, or maybe it's connected to governmental IDs. So like there's a protocol Elapsos out there that's working on that. Of course, we have this big decentralized money network, that's Bitcoin, that's built up. We have the decentralized finance platform, Ethereum, where all kind of projects are building up and building infrastructures for buying and lending. So basically replacing the traditional banking system out there. If you need some computing power, like if you have a rendering machine and rendering 3D files, you could rent that on Golem, it's another blockchain project. And as we just talked about, decentralized websites with SIA and Skynet. And I think there was a talk about serverless in the WorkerConf. So my next step is looking deeply into introducing also into my stack having a serverless functionality. So having on the Akash network is all the blockchain where you can deploy on a Kubernetes based on everyone can run a node. A Kubernetes cluster more with some resources, and maybe have there some Ruby functions that run my Ruby code, a JavaScript function that get me some external data, and to build a more complex apps, because at the moment what we're going to see now is just static websites. And yeah, that's where I'm heading now, is just to give you a quick intro how you use the building blocks that we just talked to. So let's start here. So what we see here is the Skynet web page, and what they implemented. They just implemented a simple uploader, downloader. So like whenever you want to have a file sharing, share a file with your friends, and you don't want to use WeTransfer because it might end up in some American servers and it's not encrypted. So just use this one, select the directory, what I'm doing now, what I did already before. It's going to upload it. Now in the background it's using the JavaScript SDK, what we just showed, really simple. And you get the link back, and if I open it, you see, so from the deployment into this decentralized network to serving it back, I think it's probably one of the easiest deployment methods you can have. And I have my website here, and I can view it, I can share the file, could be a video as well, and it's just going to be shared. You just have to be careful, whoever has the link can access it, and it keeps pinned like for 3 months. So like if you have some confidential files, you better zip it again and password protect it, but the storage itself is encrypted. The next thing is like I built a little really small website, so I'm using Middleman there. I don't know if people might or might not know Middleman. Middleman is a Ruby framework like Jekyll that GitHub uses this for generating static websites, blogs. I think there's Hugo on Go and a few others out there, but in the end it's just like any other static website tools. So what I created here is just like a simple page that has like a title, has an H1 image and a little paragraph in there. It's the layout, so it generates me a little web page. So I have the server running and I can see how it looks locally. So if I refresh that, that's my current page. It's called Ina Bartolomeberg because that's my domain name I purchased. Calling, I have the WorkerConf logo here. And so now we want to deploy it to Skynet. How you do that? So like for this talk I wrote a Ruby gem and a Middleman plugin to upload it to Sire. It's pretty easy. So like if you don't have a library out there for your preferred programming language, just check out the docs. It's really, they have all the curl examples, all the Python SDK and the JavaScript SDK, so you can list it. So now I generated my website and all the static files. It's ending up in the build directory here. It's the images, it's the index file. And the next is like I'm gonna deploy. Deploy is my gem I wrote, and this is now pushing it to the same through websites with JavaScript SDK to the Sire network and the Sire portal. What I get back is a Sire link, and if I have that link, I always get like this hash that I can use. So I copy that. Actually, I already did, and I just simply can paste it in here. Like it's always like the portal, different portals. You just have the hash here. I have some problems with I think there's a bug right now with the if I have call a root, it delivers me XHTML and it causes a parsing error. That's why I have to parse the index HTML. So it's gonna be fixed soon. But then in the end, like that's how I can use the portal to call the file I just uploaded on the whole directory. So we see now it's hosted on Skynet, and it's again just a reminder. It's not anywhere on the website. Anyone who has a node, I have no idea where it's hosted. It might be my NAS at home, my storage server, or anywhere else. Maybe it's served from the States. I have no idea. And that's a good thing in the end, so it's hard to block that. So yeah, what's next? What I want to show you? So now I have this normal file sharing link in the end, so people can download the things. They could get the image files as well. Now we look at the namebase website. So I have my domain settings for my Inner Bartholomäberg, and as Namebase and Sire has a cooperation, so they have a special text file where you can point to, and I'm simply setting here the link, the Sire link, in a text record, and with that I get a better domain. I can use my domain, still not directly at the moment, but I can have this name, so it's always like my domain name in Bartholomäberg .hns.sky.net, and if I call that, I get the same. So now we have really the website served through a decentralized blockchain, top-level domain management system that's called Handshake or Namebase, and we have the files that's running through the CSky portal. As mentioned, it could be any portal as well, so if someone would block the CSky portal, we could just switch to another portal and get the file served as well, so it's hard to censorship that. And the files are lying on the Sire blockchain. So going back to my presentation, as mentioned, these are all the building blocks that's out there. Don't expect it that you can run right now the best and the most powerful applications out there. It's still the early phases, of course, but as you see, it's responsive, it's snappy. You can, I guess a lot of people of you are using React. React is like really pushed on that you just build React interfaces and use the Web3 interface to interact with Ethereum, interact with Skynet or decentralized IDs. And the next step, what I was looking at, is like Akash. So Akash allows you to run Postgres and a WordPress and a PHP and a Ruby on Rails. Like there's some guides on there to build like the next level. So I don't have now a centralized hosting provider where if you upload it to whatever, Amazon or just like the German providers like 1&1, it can be censored. You can use Akash and just deploy it there. You just simply create a YAML file. Maybe have a quick look at that, just to wrap it up. That you see, it's not just like static websites. That's like how Akash is using, just as I said, like you install the app. It's like similar to Docker based. You define the resources, you define your memory, you define your storage, what you need for, or you put your storage on Sire network. So there's some guides on there. You set your price and off you go. You don't have to sign up anywhere. You just need some Akash tokens as well and deploy whatever you like. So thanks for listening to me. I hope you get the idea, what's good, what's bad, where the world is moving, maybe not, hopefully not. But in the end, we are more and more dependent on the big players, and if we all work together, we can move into a decentralized world together and build an infrastructure out there. Pretty much everything is open source, so if you want to contribute to that, just check out the Discord channels. I'm in this Sire channel because I'm running into some problems that won't work, or the documentation is not there yet, probably. But it helps anyone. We all can make the world a better place and give us selves privacy back. So Thanks for listening, and hope to catch you on the mountains or later on the Discord. Have a good day. Bye.
Next speaker is Jesslyn Jin. She's the developer advocate on Chrome DevTools. Technically, we have been on the same team for more than a year now, but we still haven't met in person because she's still in Malaysia and wasn't able to relocate to Europe yet. But I hope that we will be able to work together in person very soon. Jesslyn is an expert on all things DevTools. She's doing the what's new in DevTools for every release. She's been presenting on DevTools tips and tricks on major conferences like Google I/O or Chrome Developer Summit. In her spare time, she's actually into cycling a bit, although maybe I can get her even more excited about cycling when she's in Europe. More interestingly, she's into scuba diving, and she sends amazing pictures, like really amazing pictures. So welcome, Jesslyn, and enjoy the talk.
Hi all, I'm Jesslyn Yin. I'm the developer advocate for Chrome DevTools. I got to know about WorkerConf from my colleague, Benedict, one of the speakers last year. I'm happy to join you all this year because I'm a hike and bike person too. I would like to share some photos of me hiking and biking. I have a road bike myself. I call it Little White. And earlier this year, I tried mountain biking too. It was fun. I am based in Malaysia, Kuala Lumpur. We are a tropical country, meaning we have summer all year round. Jealous? Hiking here is always hot and humid and can get really sticky and sweaty sometimes. There's me hiking in shorts and t-shirts. I went hiking in Switzerland back in 2018. That was a totally different experience. It was dry and cold under the hot sun, and I hiked with a long jacket and pants. I got minor heat stroke because it was cold and I did not sweat that much as my usual hike in Malaysia, so I kept hiking for long hours, forgot that I'm under the hot sun and got dehydrated. Anyway, I hope everyone is safe and healthy under this COVID situation, and I hope you can resume your favorite outdoor activity. Unfortunately, my outdoor activities are stopped at the moment due to the virus situation in my country. Hopefully, with more vaccine deployed, I can get back to it soon. Alright, back to the main topic of the day. Today, I will share what Puppeteer is and how to use it for browser automation. Here is a conversation between Yang, the project manager, and Paul, the professional developer. Hey Paul, I want a daily email on our server's internet speed. While Paul is thinking, Yang continues. What I want is really simple. Just go to fast.com on the server, take a screenshot, and send it to me. Cool. Then Paul takes a look at fast.com. It's a pretty straightforward page. Now, Paul is thinking there are two ways to do this. It's not a time-consuming task. He can do it manually every day, probably within 5 minutes, log into the server, open a browser, go to fast.com, take a screenshot, and send the email. But Paul knows that this is not the best use of his time. So he did some research, and then he found Puppeteer. Puppeteer is a browser automation library for Node.js. It lets you control a browser using a simple and modern JavaScript API. After installing it using npm install Puppeteer, you can require Puppeteer in your Node script and start automating. The first step to browser automation is to launch an actual browser. With Puppeteer, that's just one line of code. Next, open a new page. This is equivalent to opening a new tab in your browser. Now, let's navigate to fast.com. This line of code ensures the page has finished loading before continuing with the rest of the script. Then, we take a screenshot and save it to a file before we finally close the browser. That's it. That's the entire script. We did all that with just a few lines of code. Try running the code now to see if it's working. Open the screenshot and oops, it's showing 0. What happens here is we need to wait until the test finishes before we take a screenshot. What should we wait for then? Let's open the page with a browser and DevTools to check what selector we can use. There is an element with speed results container CSS class. When the test is completed, it has an additional succeeded CSS class. These are the selectors we are going to use. Now, modify our code to wait for the selectors before we take the screenshot. The wait for selector methods accepts additional options like timeout, letting you set the maximum waiting time. Let's rerun the code now, and there we are. While Paul is pretty happy with the result, Yang come up with another request. That's what a typical PM does, always has additional requirements, right? It would be great if the screenshot showed the date as well. Can you help me with that? Sure. As a professional engineer, Paul reads the documentation, Google, and Stack Overflow to find the right solution. This line allows us to query the selector and change the text on screen. Additional parameters can be passed into this method as arguments. For example, here, assume we pass in a formatted date into the function as dt. Let's rerun the code again. Check the result and yay, the date showed up nicely. There are more stuff you can achieve with Puppeteer. Let's just say almost anything you can manually do in the browser, you can automate it with Puppeteer. For example, now Yang has even more requirements. He wants to generate a PDF, do some actions like click on Show Info for more details, screenshot the page in mobile view, or reload the page again for comparison. These are all achievable with Puppeteer. The Puppeteer project is fully open source and has received patches from individual contributors all around the world, as well as from companies like Mozilla, Source Labs, and Microsoft. At Google, the Puppeteer team consists of Chrome engineers who also work on DevTools. This might sound strange at first, but it actually makes sense. Puppeteer is built on top of the same underlying protocol that DevTools used to communicate with the Chromium backend. Because of this, Puppeteer also gives you access to advanced browser functionality that is usually only available through DevTools. For example, we ship a new Puppeteer API that lets you perform the same emulation programmatically. This Puppeteer script takes 2 screenshots of your web app, one in light mode and one in dark mode. It works independently of your operating system settings. In addition to that, we also added a new API to Puppeteer to let you change time zone programmatically. This script emulates various time zones and then executes some time zone dependent JavaScript in the page context. We are logging the same date, but in different time zones, and that produced different output. DevTools has a feature to emulate color vision deficiencies. And guess what? We added a corresponding Puppeteer API that lets you apply these simulations programmatically as well. This script takes a screenshot of the web app after simulating blurred vision, achromatopsia, and deuteranopia. There is more you can achieve with Puppeteer. You can use Puppeteer to measure performance. For example, you can use Puppeteer to get performance traces for a page load, get code coverage data, or to measure memory leaks. Here is a list of recipes which can help you to do so. A few debugging tips for you. Puppeteer was originally built for Chrome. So when you call puppeteer.launch, it launches a Chromium browser by default. You can now specify Firefox with product option, and then use the same Puppeteer API to test a real Firefox browser. Firefox support for Puppeteer is the result of an ongoing collaboration with Mozilla. This implementation is currently experimental. Not all Puppeteer APIs are compatible with Firefox just yet. Hopefully soon. By default, Puppeteer launches in headless mode. It's fairly probable that you would like to see how your script instructs the browser and what's actually displayed at some point. You can truly launch a browser, slow down Puppeteer when performing each operation. You can even launch a browser with DevTools open. Alright, if you would like to know more about how we build Puppeteer, follow our engineering blog at goo.girl/devtools-blog. Recently, we migrated Puppeteer to TypeScript, and we shared about how we did that. That's all. Thanks for listening. Hope you enjoyed this talk and hope we can meet physically next year in the conference. Feel free to DM me on Twitter if you have any questions. Ciao!
Next speaker is Stefan Grasbück. He will talk to you about how to eliminate side effects in developing software projects. Clear the stage for Stefan Grasbück.
Hello and welcome to my presentation. My name is Stefan Grasbück and we are Fusonic. Today I want to talk about how to eliminate side effects and call third-party services reliable and without direct implications on the current transaction. First of all, we are going to state the problem that we want to solve. Secondly, I want to give a very brief and short description about the CQRS pattern. Furthermore, I want to explain what the mediator pattern does for us. After that, we come to the solution of the mentioned problem. I will show a quick overview and the core examples of code that are going to be important. To further solidify our understanding, I will demo the solution within a project which you will be able to download yourself for further investigation. And last but not least, I want to summarize about what we have talked today. So now let's get started. Fire and forget how to eliminate side effects. So what is the problem that I want to talk about today? Well, it is something I already hinted and something that most developers have faced in their career or will face eventually. It is about dependencies. Applications typically don't operate in their isolated bubble. So almost all applications need to communicate with one or many other services. Some common interactions with third-party services could be sending an email or an SMS, notifying other services and or calling into other services, background processing of compute-intensive data. So what do they all have in common? So each call to an external system or service should happen reliably, but it is usually neither required nor technically possible to call the other services atomically within the current business transaction. So as a result, when not handled properly, lots of subtle issues can occur, which might lead to an eventual inconsistent system. This code can demonstrate this. So what happens here is that we have a register user handler, which creates a user, adds it to the current context, and then saves the changes of the context. The email sender send async is called then, which basically just creates an SMTP client, sets up an email message, and sends the email. So what can go wrong here? Well, the happy path is when save changes executes correctly and email sender send async also returns correctly. So everything is good. The user is saved and the email is sent. The consistent error path would be when save changes fails, the user is not registered, and no email is sent. This is not good for the user experience, and an error page will appear, but at least we return to a consistent state. The problematic error path would be when save changes succeeds, but email sender.send async does not succeed and it fails. So this is not good for the user experience because an error page will appear. The user gets registered, but he does not receive an email. So he is in the system, but he doesn't know that he is. The fourth error that can occur is if save changes succeeds, but the auto transaction of the request rolls back. So what actually happens is the DB context save changes succeeds, email sender send async sends the email, but the ambient transaction which encloses the DB context save changes async rolls back. So also the changes of this transaction are rolled back. So the user is not saved in the database, but he got an email that he is registered on the site. Before we talk about how we can solve this problem, I want to refresh some key practices and patterns. CQRS stands for Command and Query Responsibility Segregation, a pattern that separates read and update operations for a data store. The mediator pattern promotes loose coupling of classes by removing direct dependencies. It can also simplify communication in general when a program contains a large number of classes that interact with each other. So how do we tackle this solution this problem that I mentioned before? So the solution is a reusable outbox pattern, and what an outbox pattern is what I want to show you here. So we have the register user command handler, and whenever that succeeds in registering the user and saving it to the database, it saves with the same transaction, it saves a send email job to an outbox. This could be, for example, a simple table where a job is stored, send an email to this user. And this all happens in one transaction. So if the user is not changed, also the send email job is not saved to the database. An outbox processor then, in a second transaction or in a second flow, fetches the data from this table and processes these jobs and eventually sends the emails. How can we make this code reusable? So we can use Hangfire as our job processing queue. Hangfire stores the job in its own database scheme and can be set up to even automatically retry whenever a job fails during execution. Decorators allow us to add to the current behavior of a class. By decorating the requests that we want to execute outside of the current flow, we spare us to create, for example, a Hangfire send email or an Hangfire notify admin. So we can decorate both of these requests with a Hangfire decorator, and we save us a lot of boilerplate code. We can also rely on the dependency injection container pipeline to resolve our decorators, as this is deterministic, for example the simple injector. In C#, it is pretty easy to mark an interface or a class by an attribute, and with this we basically mark it to be decorated. So how does this work? We have our DI container here, which has two requests, request A and request B and request A. And request A is marked with an attribute. So whenever we call register decorator for all T requests, so for all requests of this type, which are marked with an attribute, the dependency injection container then looks as follows after that. Request B is unchanged because it was not marked with an attribute, but request A got decorated with the decorator because it was marked with an attribute. How does this look in our concrete example? So we have the request B and we have the user registered example, the user registered request, and the user register request is marked with an out of band attribute. So I call then register decorator for all T requests marked with an out-of-band attribute. And dependency injection container looks as follows. We have request B, and we have the decorator of user registered with the decorated request here. And it's still marked with the out-of-band attribute. So now on to the demo. So what this code here shows is very similar to what we have seen on the slides. I want to show you the startup class before, which calls container register out of band decorators, which is an extension method provided by a Phosonic NuGet package that is open source. So register user just gets just is a command basically with an email name and a surname, and it creates the user, adds it to the current context, and saves the changes. After that, it calls mediator.publish, and mediator.publish just basically calls an event of user registered, which then, for example, sends an email. So if we step into this, we can see the notification, the iNotification user registered, and this basically does nothing, but you can imagine that it could be sending an email. So we just log sending email to this user. So when I execute this, you can see we're using Swagger here. So I just click on try it out and I send the request, and we get the status code to 200 with the response, which is what we expected. So what happens now if I, for example, have the sending of the email fail? So I'm just throwing an exception here to basically make the sending of the email fail. So we expect 500 internal server error. Again, we try it out, we hit execute, and we already provided with the exception here. Click on continue, and we see that we got a 500 internal server error with the stack trace here. So how can we resolve this, that we actually can save the user when still the sending of the email fails? So we can achieve this with the out-of-band attribute. So this attribute here marks this notification to be decorated with the out-of-band decorator, which then allows us to execute, to apply the outbox pattern basically. So what I expect now is that we hit the exception, but that we still get a response code 200, which is successful for storing the user. And we get it. We get a status code 200, and in a moment we will hit the exception. Yes, so we hit the exception here, and we can click continue. And if we look at the output window, for example, you can also see that it even has an automatic retry implemented with an exponential backoff. So this demonstrates how to apply the reusable outbox pattern for this problem. So implementing the outbox pattern on top of Hangfire is a nice and easy solution for solving these common service-to-service communication issues. Using our open source Phosonic extensions Hangfire integration package, you can easily plug a reliable outbox solution into your system. So if you're interested in learning more, David Roth, our head of development, has published the sample application that I just showed on GitHub. I hope we could provide you a good insight on how we tackle these problems. At Phosonic, we are constantly striving to be one step ahead and are therefore always looking for great people to join our team. We are currently looking for project managers, developers, designers. And if you're interested in how we work, please get in touch with me or visit our website phosonic.net. I hope you enjoyed this talk and thank you for your attention.
Guys, you know what? Doing open source is sometimes really tough.
So, the only altitude this guy usually does is through bar or ring muscle ups. But also, he's flying high as a web developer for sure. Welcome, Vorarlberg's strongest developer, Shahin.
Hi guys, welcome to my talk for today. Hope you're doing all well and are enjoying the WorkerConf until now and will also enjoy the other talks. I'm a bit nervous and excited actually because this is kind of my first time giving a talk at a conference like this, and I really appreciate the opportunity, so hope you can enjoy my talk. I'm going to talk a bit of a new standard we want to achieve at our agency, and we'll give a bit of a background information to that. As you can see maybe on the title, it's going to be about Vue 3 and the composition API, and also involving a bit of Tailwind and Storybook, but I will explain it all in a bit. Before we go into the topics a bit more in detail, let me introduce myself quickly. I'm Shahin and I'm working at Toba as the head of development. Toba is like a digital agency. We are based in Austria, in Bregenz and in Vienna, and we do work in the area of CMS application and enterprise level e-commerce projects. Our main stack involves actually PHP and JavaScript, and we do use like framework and tools like Vue, Nuxt.js, Storybook, Laravel, and Spryker, and a bit more. Yeah, but that's it actually to my person. That's me in a nutshell. And what we are going to talk about today, I'm gonna give you a bit of a background information, how I came up with these topics actually, or how like evolved it. And then we are going to show a bit talk a bit about Vue 3 and the composition API. I prepared a bit of stuff because I was a bit afraid of live coding, such a setting. Just want to go everything smoothly. And also we're going to talk a bit about, as I mentioned, Tailwind, which involves the Tailwind CSS framework and the UI component library of them, and also the headless UI library, which they introduced a while ago. Yeah, so nothing too fancy, and I want to keep it simple for today, and I hope you can enjoy these talks. Let me explain a bit the background of this whole talk and how we came up with these topics. A while ago, we partnered up with another agency to work on a multi-brand store project. It's actually currently ongoing. And on the other hand side, you can actually see the project setup. Like the project setup is the same. And I copied the most of the stuff, but left out all the other stuff because I wasn't sure if I can show you that actually. And I just prepared some things which are going to be in the project, which involves, for example, like a product grid and a search functionality, which was developed here with the composition API. So we had the opportunity to define the whole technology stack for this project, and we didn't have any limitations, which was great news. It's not always the case. And then we came up together with the following, which is listed on the slide. We are using Vue 3 and the composition API as like a guideline and as a like a go-to architecture. We decided to use Tailwind as the main CSS framework and also agreed on to use the UI component library of them and also the headless UI. Storybook is in place. If you don't know it, go check it out. It's really a neat tool which works with different kind of frameworks, also with React, Vue, and a bunch of others, which is like in own words basically a kind of a sandbox where you can develop all your components, test them, document them, and get it approved by a customer or your product owner or whomever you are going to show it. The whole setup actually also involves Jest as a testing suite. I'm not covering that today. At the moment we are doing some basic snapshot tests, which will be also extended with some feature tests in the upcoming weeks. And there's also White in place, but we don't need it at the moment because we are working with Storybook, but we're going to check it out definitely also for our own stack. Yeah, and with this project, actually, we will take the opportunity to introduce especially the marked technologies and tools as a new standard for our own projects, meaning that we are going to use Vue 3 and Tailwind and Storybook combined in our front-end related setups. Yeah, so now let's start with Vue 3 and the composition API. I'm looking down there because I have some notes prepared so I don't forget anything. Just a small reference slide. So I guess most of you guys know Vue as a framework, so I'm not going to explain how it works, etc. Also not going too deep about the composition API, how it works. I'm just gonna show you some samples. And but just a small reference slide for the composition API. So it's kind of an internal API of the framework, which is available since Vue 3. You can also add it actually to Vue 2 as a plugin. And the benefits are actually like it makes your code more reusable and like the readability of your components gets a lot better actually. It helps you to like extract logical features or like functions of the component and then introduce them as dependencies, basically explained a bit really like on a high level and in words, but I hope you can follow that. Yeah, let me showcase you a bit of stuff. So I will open my editor and here on the left side, like from my left, you can see actually Storybook already up and running on my local host. And here you can see the whole project setup. We are not going to talk about the structure, etc. But we are going to talk about the whole setup in general. So as I mentioned, Storybook is in place. As you can see, it's actually showing me some stuff already. It's really great. I prepared like a sample page. It's actually our own feature in Storybook where you can put together like a whole template, so to say, with the whole components you are developing in the project. And then you have your library actually. So this is like pretty basic. I just have like a footer. I have the header, and I have the product grid. Yeah, here. And as you can see on this simple front page, I put them all together. And I will also show you how this looks like in the code. So it's pretty basic. You are actually working just with Vue components. And then you can define Storybook stories, which are then passed into this whole application. As you can see here, this is exactly this front page on the left side, where we have our header, the product grid, and the footer. And we also define like a property, the products, which are coming now from Storybook. They are like defined here. That's also a great feature of Storybook actually, that you can just pass in arguments to your component. And yeah, this is basically it. So like I can showcase you this, and also on a component level, as you can see here, we do have a bit of more components defined here, but only showing 3 of them. That's because we are or we only defined 3. This third one is here actually, like the page footer, the header, and the product grid stories, and they will all pass automatically into this application. Yeah, I hope that wasn't too fast or anything. Let's go a bit more into details. I'm going to show you what I did actually with Vue 3, 2 specific things. I'm going to show you the one feature of the composition API and the provide and inject method actually. So as you can see, we do have a product grid here with just some sample data, and there's a search functionality which is really basic, so I can just search for the name and which works out of the box, or like not out of the box, but a pretty simple search on the title of the project products. And I did this with the composition API. Let me go a bit into detail and explain you how this works actually. So if we have a look at the product grid, it's pretty basic. This is this whole grid. So we do have our product grid search here, where we have a look a bit more in detail in a bit. And here is the grid with the product grid item. So the component product grid item doesn't do anything special, actually just renders out this single component. And as you can see here, the whole component is pretty compact. It's nothing too fancy, pretty cleaned up. Of course, also for the showcase, I guess in a real world project, when we add some features, maybe some filters or like sorting, then this will be extended a bit, but it will still keep the component logically compact. What I mean by that is, like, with the search functionality, it's included, as you can see here on the line 22. I defined a use product grid search functionality, which is introduced through the composition API. We'll have a look in a moment to that part. All the other stuff is not so, like, it's pretty straightforward. I just include the components, define the products array, and this is actually where the magic happens. So this setup method is new with Vue 3, which is basically the main go-to function if you define anything props or functionality related. And here is actually the search functionality included. How this works is I created our own JS file only for the search. This is pretty straightforward. So it just exports a default function called use product grid search, which gets the products, and there's the search query, and I'm returning actually the search query and the products matching the search query. So this function is pretty straightforward. It just filters all the products based on the name and the search value I'm typing into the input box. So this is basically like an encapsulated functionality, right? So I searching for products, I'm awaiting a product as an input parameter, and I'm returning the search query and the matching products. One special, or like two special things here already. We are importing the ref function and the computed function from Vue. There are new since Vue 3, and what this does is actually I am defining the search query as a value, like as a variable by reference, and I'm defining the products matching search query, like basically the products which are matched are defined as a computed property. So in this way, as you can see, if I search for something, then the whole grid changes automatically. To include this in our grid, I showed you just can import this. So like I'm importing the use product grid search here, and the search query and the matching products. Ignore this line just for this second. And then basically I'm returning this for this component, right? And this is actually, so like the products are actually used here. And the search query you will see in a bit is used in the product grid search. And that's basically how the composition API works. So it gives you the possibility to like encapsulate some logical function of your component somewhere else, like other than inside your component, and then gives you the possibility to import it and use it in a pretty simple manner actually. You can do this, of course, like with same functionalities like the filter or like fetching products from an API maybe. So you just define a function where this happens and then introduce it here in the setup function. Yeah, so that was a bit into the composition API, so really simple and short. There's a lot of documentation, like how it works in detail, also to the important functions like the ref and the computed, but they basically do the same as you already know if you work with Vue. So like the computed means it's a computed property. It just gives you the opportunity to use it more dynamically. Yeah, that was like a bit of the composition API. Now let me show you also an interesting concept which is called like the provide and inject, which basically helps you to pass like parameters or like props to child components. Maybe you already done this by just like if you have a component tree where you have a parent and maybe 2 or 3 levels of child components, you can of course pass them through the whole hierarchy of your tree, which is but maybe not always so like comfortable to use, or like it gets a bit messy because you always have to pass it through your component even it doesn't do anything with it. And now you have like the provide and inject functionality, which just mean I can define here on the parent component a variable like a key which is exposed to the child component, and I of course can define what should be in there. In this case, I'm exposing the search query because I integrated the product grid search as a own component, like as a child component. Of course, I could also have like just passed in the parameter and made sure that the mutation or like the synchronization of the component model happens. But with the provide and inject, it's really easy. So here, to use this, you're importing your provide function from Vue, and then I'm exposing this variable to my child components. Now, if we look at the product grid search, which is basically only this input box with a bit of styling, you can see that I defined a model here, which is connected to the input. And here it's pretty straightforward again. And as you can see, I'm importing here inject, and I'm looking for this key and telling my component, okay, your model is basically assigned to this search query. With this, it's possible that I can use the child component and have still my search functionality working. Otherwise, it wouldn't work because the the computer property wouldn't know that the search value has changed, and then wouldn't happen anything actually. So with this functionality, it's like kind of neat. Of course, you have to make sure that you know which which variables are exposed to your child components, but it's a really interesting way of kind of providing some dependencies to your child components. And it's kind of also like works like a dependency injection, right? So I'm again just providing here something and injecting it here. Pretty straightforward. And I want to show you those two functions again. The search functionality through composable. That's like I think it was mentioned in the Vue 3 documentation. They use this naming. I like take it over because it kind of makes sense. And with this, I integrate the search functionality, and I provided also to my child component parameter which should have some binding basically. Yeah, also, of course, like this functionality is not limited to this component, so I could use it wherever I wanted. So if you go maybe a bit further, you can probably generalize this product grid search into a normal search where you just pass in array of items which you want to search, and then also the search query. And also, if you go like a step further, you could give like the callback how to filter it, right? So and then you would have a really general search functionality where you basically can use anywhere where you want to search for anything, and then you have like less code repetition, or you can reuse your search functionality. Yeah, that was it actually for the whole Vue 3 and composition API part. So it's an ongoing project, and I want to make further content about that because I think it's really great. And as I mentioned, we will introduce this as a new topic, like as a new standard in our agency. And we see a lot of benefits like reusable components, extracting functionality, keep your components small and clean, less error prone, and yeah, I hope this kind of helped you to see maybe how you can use it. Cool, then let me switch back to the presentation, because I want to also talk a bit about Tailwind and headless, like a Tailwind CSS, the UI component library, and the headless UI. And yeah, also here just a small reference slide. I assume, or even if not, nothing to worry about. Tailwind is like a utility for CSS framework. It's actually my favorite one. And a while ago, it was extended with the Tailwind UI component library. So this is basically this one. You can just have a look at the tailwindui.com, which gives you a lot of like prepared and really nice usable components, either for Vue, React, or like just barebone HTML. And furthermore, they also introduced a couple of weeks ago, or I'm not sure when exactly, but a while ago, the headless UI. What this is like, in my own words, it's like functional UI components without any styling to integrate into your Tailwind CSS projects. And I'm gonna show you an example what I did there, and I used actually one of these components. As you can see, they're supporting React and Vue, and you can just go through the documentation. It's really great. And I actually use this menu, like the drop-down element of their headless UI. Yeah, in this case, maybe just let me show you. It's actually this drop down here on the top right. As you can see, it's a drop down with a couple of links. Nothing fancy. I didn't also style it too much, so like it's all basic. Also, the whole project is pretty basic and from the component library actually. So like this whole footer is from the Tailwind UI component library, which also all works responsive if you want to check it out. Pretty neat actually. Yeah, so nothing too fancy on the front end, right? So let me show you the code behind it. We're gonna open up for that. Let me close this all stuff. Let me open the header. So here is all the code for this, for the header, right? So let me switch the components that you only can see this. So this is all the header, all here. There's nothing fancy going on, and it's just this drop down. And as you can see, I defined it as a own component, and we will have a look into it now. Let me open that. As you can see, what the headless UI offers you is actually a bunch of functional components. You can see a couple of them here from the headless UI view, and if you use React, you can just add React here, and I'm just using them as components. And yeah, as you can see, so I just lost my thoughts for a bit. So I'm using all the components from that library, and it's like how the structure works is well documented. So I'm using the menu component, and like all the functionality regarding this opening up and closing, which is also accessible via keyboard and such, is all defined in the component itself. You can check out the components on GitHub actually. And I just followed the documentation, basically how to use it. And for example, here we now have the menu, which is this item. We have the menu button, which is the drop-down, is exactly this one. And then with the transition component from view, I'm using it as a container for the menu items. And here are all the menu items themselves. They are not super fancy. We don't have to look at them actually. And what combined with Tailwind CSS, you can just style them as you want, right? So I can tell this menu object to render as a div. You can use any other tag which you wish for, and then just give the classes you need. So I could use this menu, like this menu functionality, wherever I need it, and just style it the way I need. But I don't have to worry about the functionality, like so the opening up, the closing, and also working with the keyboard, as you can see, escape button and so on. And that's basically it. So like in my opinion, combined with the Tailwind CSS framework, it's really great and works out really nicely, where you can just include some functionality and style it as you need them. So you don't to worry about the functions behind it. And there's a great documentation about some additional component API or like the options of these components basically. Yeah, that was it actually for the Tailwind and headless UI stuff. And that was it actually. So I hope you enjoyed it a bit. I'm still nervous, but really happy that I made this talk. And I hope that I can do more in the future and then also be a bit more relaxed and show you more details about some topics we are working on or I'm working on. Yeah, so in this case, thank you for attending my talk. I hope you enjoyed it. I would love to hear some feedback. I hope it was clear enough, my voice, my English, or like the topics, were they in depth enough, whatever. I would really appreciate any feedback so I can improve my speaking skills. In this case, all of you take care and enjoy the rest of the talks, and really thank you for the opportunity, and that's it from my side. Wish you all the best. Bye.
stressen.
A few weeks ago, I did a small e-commerce project and I got caught by the sandbox trap. I used an enterprise feature during development and switching to the smallest plan was not possible anymore. Paying the enterprise rate was also not an option, so I needed something else. I found Vendure and got in contact with Michael. His support is world class. Now enjoy his talk.
Hi, my name is Michael, and today I want to talk to you about my project Venture, which is an open source framework for developing e-commerce applications. Now, why, you might be thinking, should I be interested in e-commerce development? Well, as you might have noticed over the past year or so, due to COVID, there's been quite an increase in activity with e-commerce. And as a result, there's been a big increase in demand for applications to serve this need. So there's a lot of developers finding themselves having to develop e-commerce applications. And if you happen to fall into this category now or in the future, then my hope for you is that you have an enjoyable and productive time of it. And that's my motivation behind this project. But before we get into it all, we need to back up a little bit, and I need to give you a little bit of context about how I came to start this project. So when I was a kid, my parents started in a shop selling art materials, paints, brushes, paper, and so on. At the time, I was pretty good with Netscape Composer, so my dad asked me to build a website for the shop, and of course I gladly agreed. So, it was static HTML, years ahead of its time, and the best part was the order form was just a form that the customer would fill out. It would then email it directly to our inbox, complete with the payment details. Those were simpler times, what can I say? Anyway, a few years later, we needed a better solution, so I bought this book, which had a whole chapter on building an e-commerce application. It was perfect. It was meant to be. As a fun fact, 15 years later, our core files for our shop still use the same naming conventions given in this example. Anyway, fast forward to 2017, and we've finally reached the limits of my haphazard solution. We needed something new. By this time, I've got a lot more developer experience under my belt. I've been working for the past few years on the team of an open source CMS, and I was really into TypeScript and the NPM ecosystem as a whole. So for our new website, I made a survey of the current e-commerce development landscape to help us decide what we should build our next iteration upon. So of course, the first major choice is between software as a service, SaaS, or self-hosted. So some of the well-known SaaS services for e-commerce include Shopify, BigCommerce, and Commerce Tools. And for many businesses, going with the SaaS route makes a lot of sense, but not always. Factors such as pricing models, the features, and the ease of extension mean that sometimes a dedicated framework for custom development does make more sense. So since the early 2000s, when I had started working on my PHP website, there had been a proliferation of open source e-commerce frameworks. There's lots and lots and lots that I was trying to evaluate at the time. Here's a selection of some of those that I researched at the time. And there's a few interesting points about this chart. Firstly, by this time in 2017, many of these solutions were actually quite old, around a decade or so, give or take. Now, being old in itself is not a bad thing at all. Being old implies feature completeness, battle-tested, robust. But at the same time, it can also imply an outdated tech stack and maybe a not ideal developer experience, right? The second point is, if we look at the underlying technologies for these frameworks, there's a trend going on right here, right? Now, I don't hate PHP at all, but if I could choose, I'd rather use something like TypeScript. Reaction Commerce was at the time the only major e-commerce framework that's targeting JavaScript. And for me, it was a real shock to see that this huge community of JavaScript developers was completely underserved. And the third thing that's interesting is that all of these solutions at that time are monolithic, by which I mean the storefront and the server itself are coupled. So when a customer comes to the website and wants to view a product page, that request goes to the server gets the data from the database, puts it inside a template, and serves the completed view back to the customer. So of course this is not really surprising, because at the time that's the status quo. This is how you built dynamic websites. But what's interesting is that I had spent the previous 3 years working on a headless CMS, an open source CMS, and I'd really kind of come to appreciate this headless architecture. Now in 2017, headless was still kind of niche, and specifically the idea of headless e-commerce had not yet reached the full-blown buzzword status that it enjoys today. So this is the context around how I started building my own solution. My aim was to create a truly modern, headless e-commerce framework built on technologies that I personally enjoyed using and find really productive. And at the same time, these technologies also represent this huge underserved community of developers around the world, namely Node.js, TypeScript, and GraphQL. And if we think about it, if you're building a web application, you need to use JavaScript, for the front end at least. And these days, the chances are that you'll be actually using TypeScript. So let's make it now possible for developers to create full stack TypeScript e-commerce applications. Enter Venger. So I've been working on Venger for about 3 years now, and just last month we released version 1.0. It's in production in projects large and small, but I'm not going to go too much into the marketing side in this talk. If you're interested in case studies and feature lists and that kind of thing, check out the website, venger.io. For now, I want to concentrate on the developer experience. So to get started with a new Venger project, you would use npx venger create. This is going to guide you through the scaffolding and configuration of a brand new project. You tell it what kind of database backend you want, the credentials, and so on, as you can see here. Now, Venger itself will run on a number of different database backends, and resource-wise, it's not very demanding. For example, we run our demo instance on a $5 a month DigitalOcean box with SQLite, so it's definitely going to run on your machine. Now this process is going to also populate the instance with some test data, so you can be up and running straight away and try things out yourself. The installation takes a few minutes, so let's fast forward until all that's done. Alright, so now we've got a full e-commerce server up and running. Let's check it out. So we're inside the directory it just created, my shop, and we'll run yarn start. This is going to start up the server and the background worker. Now the server's up and running. Let's take a look first of all at the admin interface. So let's log in with the credentials that we supplied at the start. Alright, here's the dashboard, and let's just take a look at a few of these screens. So we've got a list of products, which we can edit and view the variants. We have collections, and we can organize our stuff. We don't have any orders yet, but we do have a bunch of assets. Okay, let's see what else we can play with. Alright, so in development mode, we also bundle the GraphQL Playground. So this lets us just run some arbitrary GraphQL queries. So we can see that the server's responding as we expect there. We can change parameters here. There we go, so that's all working nicely. Alright, we'll just stop that. And now let's look into the project itself. Let's see what we've got in there. So, as we can see, we've got node modules, of course, and a bunch of the usual config files in the root. And really, the project itself consists of just 3 files. Index is how we start the server. index worker starts the background worker process, and really everything interesting happens here inside the Venja config file. So one of the design decisions that I made while creating Venja is that I wanted all configuration to be really localized, so that if you have to change something, you know exactly where it's supposed to go and where to look to see what's going to be changed. In doing research on various other frameworks, I've had the experience that sometimes pretty simple changes mean that you have to jump through a bunch of different files in different parts of the code base just to do, like, I don't know, add like one property to a model or something. And sometimes you end up having to configure various like YAML and XML config files. So that's something that I wanted to avoid with Venja. And I tried to make everything, all the configuration is code, it's all TypeScript, and it all lives in one place. So I'm going to give you an example of how easy it is to configure something. So let's take, for example, we want to add a custom field to a model, which is something really common. In our case, we're going to add a weight field to the product entity, so we can store product weights. So what we would do is come down here to our custom fields configuration, and we say we want to add it to product, and we want the name to be weight, and we want the type to be, let's say, an integer, and let's say we want to set a default value, which would be 0. Now the cool thing about TypeScript is that we get type safety, so if the default value is given as a string, it's an error. So that's one nice thing about having the config as code rather than a format like YAML, for example. Okay, so that's all it takes really. So let's go back and we'll kick off the server again. And what this is going to do, that one line change, is going to do a few things actually. It's going to update the schema in the database, adding a new column for storing the weights. It's going to update the GraphQL APIs so that when we update or create or query a product, we now have this new field. It's also going to update the admin UI so that we can actually enter the data for the weight into the UI when we're editing a product. And I'll show you that now. So let's go back over to our admin UI, log back in. So now if we look at a product, we now see that we have the custom field weight here, and then we can set a weight and save it. And now if we look over at the GraphQL playground, so we should be able to ask for custom fields, and we should be able to ask for the weight. Okay, and we can see right here that we get the weight of our laptop as 8, which is, I think, what we put in here. So that's all working. So there we go. So a simple customization, which is very common. I tried to make it really as simple as possible, type safe and intuitive for the developer. So when you're developing a real application, the customizations are not always that straightforward quite. So let's take another example, which is now slightly more complicated. Let's say we want to make it so that customers can upload an avatar image for their profile. Now this involves something like creating a new image, which we call an asset in Venja, making some kind of relation with the customer, setting up so that you can update the image from the mutation, which is updating the customer, update the GraphQL APIs to embed this image type inside the customer custom field, and updating the admin UI so that we have like an image upload and selection widget to go in the customer detail view. Okay, so quite a lot of things going on here. So let's see how this would look if we want to set this up with Venja. We'll go back into the config again, and so now we're going to set it up for customer, a new custom field. We'll give it a name, avatar, and now this time for the type, we're going to have a type called relation, and the entity is going to be of type asset, which we'll import now. It should have done that automatically. Good. Okay, actually that's all you need. Let's restart the server and then take a look. Alright, so let's go over to our customers. Now we don't have any, so we're going to create a new one. Okay, and as you can see, we actually have this custom field now, an avatar, where we can select an asset. Let's upload one, and that's handy. Let's choose that one and create. So these examples illustrate the overall design philosophy with Venja in regards to developer experience, which is make things simple, productive, type safe as much as we possibly can. Now we've got a working GraphQL server, we've got an admin dashboard. There's one thing missing. How do our customers buy our stuff? Of course, that is the storefront, and that is the one thing that we don't ship, and we don't handle that at all. Now there's a few reasons that we don't do anything with the storefront. Number one, I am just one person and I have limited time, so I've had to make the decision to not specialize on doing a storefront as well. It would just be too much work. Secondly, each team will tend to have their own preferred competency, their own stack, their own framework that they know and love and they want to use, and it's quite varied. And thirdly, one of the benefits of headless e-commerce is that you can craft these really custom, unique shopping experiences. And these don't really lend themselves so readily to some kind of out-of-the-box component kit or pre-built storefront. Having said this, there is immense value in lowering the barrier to getting into headless, because having to build a whole storefront from scratch is quite an undertaking. So to that end, I've been working with Vercel and Vue Storefront, who respectively have some really nice solutions for pre-built storefronts in Next.js and Vue. And we've been working on official integrations for Venja. The Vue Storefront integration is still under development. It's being run by some community members. It's not quite there yet, but the Next.js integration just landed actually a few weeks ago, and I'm going to show that to you now, and we're going to get a storefront up and running to go with our backend server. We'll start off by cloning the Vercel commerce repo and pull that down locally. Once it's been cloned, we'll move into that directory and run yarn to install the dependencies. Now I'm going to fast forward this bit because some of you already stare at screens like this too much in your day job. You don't want to see that in a conference talk. Alright, dependencies are installed. Let's take a look inside that project. So this is a fairly standard Next.js project, but we also have this framework folder which contains the different integrations that are already available. Here we see inside the Venja folder, there is an environment variables template file. Let's copy that and place the copy in the root, and let's rename it to just be .env. One other thing we have to do is point it to our local server that's running. Okay, now we should be able to run yarn next dev, and we'll set the ports to 8000 so we don't get a conflict on port 3000, and start that up. So next is telling us the website is available on localhost port 8000, so let's click through onto that. Okay, and here we have our storefront, and we see the items being populated from our Venja server. Let's buy something. That mouse looks kind of nice. Okay, let's add that one to the cart. That looks good. So we have it there in our cart. And now let's just verify that it's all actually hooked up as we expect. If we go over back to our admin dashboard and look in orders, active, we can see right here that our mouse is right there in an order. Let's just double check that. Let's change the quantity to 2. Refresh. And there we go. So there we have a fully functioning e-commerce backend, admin interface, and storefront in 20 minutes, which is not bad at all. There's a whole bunch of stuff that I've not even touched on, like the killer combination of GraphQL and TypeScript and the end-to-end type safety that brings, the ease of integration with external tools like headless tools like Storyblock, and there's a whole ecosystem of headless parts that can be composed together nowadays. The buzzword is composable commerce. Google it. So thank you very much for watching. If you want to find out more, head to venture.io, and thank you for your attention today.
Oh, I didn't see you there. Welcome in Vienna. What a wonderful day. Tomorrow is Friday, and you know what it means? Tomorrow is WorkerConf online. It's the first time I see this online. I'm going to be there as well. And there's going to be one special guest, Sean Grove. For those people who don't know Sean Grove, it's an old colleague of mine, so I know him pretty well. He's the founder of OneGraph.io. It's a platform to connect all the different SaaS services like Zendesk, GitHub, Twitter, like all the platforms you usually use in your business, and connect them all together in one single GraphQL endpoint, which is pretty mind-blowing when you think about it. So he's going to have a talk at WorkerConf about next generation API clients and owning your abstractions. He knows a lot about gluing data together. And he also knows a lot about GraphQL and product development. So I am really looking forward to Sean's talk. Check it out.
I'm going to be talking about next generation API clients for integrations and how you can move much more quickly in your projects with them and still maintain your own abstractions. So a quick aside about me, my name is Sean, coming out of San Francisco. In a previous life, I ran engineering for a payments company where we built and maintained hundreds and hundreds of integrations. That led me to join my current company where we deal with integrations on a massive scale. But I won't really talk about that specifically today, other than some experimental work we're doing, trying to reify and make concrete some of the best practices. Other than that, I have a background in a lot of developer tooling. Good DX, good UX is kind of near and dear to my heart. So I'll be taking a deep look into integrations today, in particular the steps of building them, debugging them, maintaining them, some of the challenges that come along the way, and some of the best practices that can be extracted so that you can build kind of a integrations as a service, if you will. And we'll also be taking a look at some of the experimental demos around these best practices that we've been working on. So for the purposes of today, the integration we're going to be working on is adding a enriched GitHub signup flow. So in this scenario, we already have an email flow that a user can sign up with, where they'll fill out an email and password, fill out some personal information and some company information. So about 3 steps that the user takes. We want to offer an alternative flow where they can sign up with GitHub. We'll take that email, we'll then enrich it via Clearbit so that the total steps required for a user to move data is 1. To set the scene, let's take a look at how I think this integration could be done in the ideal scenario, kind of using some of this experimental practices that we'll talk about. And then we'll break that down and compare and contrast it with how things are normally done. So over on the left, I can see the pre-built blocks, either by me or by other people that have been shared. Some of them will just be individual actions. Some of them might be a collection of actions. But I can click on them and just see exactly their inputs and their outputs. But in this case, because the chain is so short, I'll go ahead and just create it from scratch. And this first query is going to go ahead and go into GitHub and get the current user's emails. So I can see it over here, the catalog of all the available APIs, and I can kind of drill into the part that I care about. So I'm going to go into GitHub and viewer, which is the currently logged in user. I see email, but also a special field, which is a privileged email field. So if this is the currently logged in user, then go ahead and grab the email, is primary, and is verified. So I see exactly the data that's going to be coming back here. And I can get an immediate preview of the structure. So these are objects. This is an array of objects, booleans and strings. Let me go ahead and just execute this. And you can see that I'm already logged in. So it came back with a list of emails. So that's the first one done. Now let's go ahead and make a second block. And this one is going to use the Clearbit API, which has an enriching functionality, but it's going to take email as a variable. And based off of that, it's going to reach into the company of this particular person. You get their domain, we'll get maybe their location, their name, and their logo. So again, I can see the inputs and the exact output. So now I'd like the data from the GitHub user email to flow into the enrich email. And I'm getting an error immediately because it's telling me that this enrich email requires an email input. So we can go ahead and start computing that. So let's drag in some data from this. We'll get a list of all of the emails. And instead of just the first one, we'll use all of them. And now maybe we want to go ahead and say email is going to be this value dot find. And I want to return whether this is both the primary and if it is verified. And so if we get that, and you can see that this is coming back already. And this actually doesn't look quite right because I just want the actual email. If I were to return, for example, email here and email, I would get an error saying that, hey, I expected a string and you gave me this kind of structure. So I'll go ahead and just come back here, and if we have some value, I'll grab the email. Similarly, if we don't have an email, I will just return early. And let's make that pretty. So there we go. I was able to add my custom transformation logic and visualize it inside of here and know exactly the data that's coming back. All right, with that demo in mind, let's go ahead and compare and contrast that to the way that things are done right now. Where in the lifecycle of integration, the first step is typically to read the API documentation. And the thing is, by the time you read the API documentation, the product has probably already sold you. It said, I can do X, Y, and Z, and you thought, oh, great, I need to do X and a little bit of Y. So you come into the documentation with some use cases already in mind. The thing is, where you start with the documentation may be very, very distant from actually figuring out how to achieve your use case. And fundamentally, every API has three capabilities that it offers. So the first is going to be read. It might have some data that you care about. The second would be write, where it can perform some sort of function, maybe storing some data, creating a payment, sending an email or an SMS message, or it can notify you of some change that has happened in the world so that you can react to the things that you care about. So it can kind of align a API along these different axes of read, write, and listen. And if you're familiar with GraphQL, this should seem pretty familiar because these directly map to query, mutate, and subscribe. Now, when we first enter into the documentation, we have a use case in mind. Maybe it's a little bit in the upper right of this graph. And the documentation is this blue here, where it's describing the capabilities of the API and saying, hey, we have some queries over here that you can get out once, or you can subscribe to changes, and some read and writes that you can do over here. But our use case isn't necessarily close to all of those. So we're probably going to have to work our way through it. And this is the worst with documentation that simply enumerates capabilities and says, hey, I have all of these endpoints. And then it's up to me as the reader to figure out, well, is this endpoint relevant to the use case I'm trying to pull off or not? Of course, a lot of them are going to have better organizational stories. They will have maybe objects and say, hey, we have a payment object, and here are all the things you can do that are related to payment objects. And this is nicer because it gives you a sort of gradient vector where you can work your way through the documentation and tell, am I getting closer to my use case or am I getting further away? And use that to course correct and kind of hone in more quickly on how to achieve your use case. Unfortunately, very few API docs actually have extensive examples where you say, hey, if you want to do X, this is as close as possible as we can get you to it. And that's unfortunate because examples are effectively bookmarks into this space where I can take a quick look at an example, determine whether or not this is close to what I want, and then jump to the next one. So I can kind of quickly jump through the space, and once I find one that is sufficiently close, I can go ahead and then maybe take that and tweak it to get to my use case. So the first challenge in building an integration is that exploration is typically somewhat difficult. Depending on where you start in the documentation or with your integration and figuring out the path to get to your actual use case. And what might be nice as an alternative, kind of what, as we saw in the demo, is if we could capture the source API, where we say, here are all of the bits of data that are available inside of the API, all their types, whether they're nullable, etc. And then we could use that as the source of truth, both for the data as well as for the effects and for the events that we could listen to. And GraphQL obviously does this pretty heavily, but this is not a new idea. OpenAPI is hugely adopted, and it's also not a new idea by any means. This goes back a few decades at least with SOAP. And then we have some more recent additions to the family, like Async API. But effectively, all of these are trying to capture information about the source API so that we can rely on it in a confident manner. And so what we could do is maybe capture all of the APIs upstream that we rely on and put them inside of a catalog as our source of truth. And by capturing the source of truth and the effects, we know all the data that's available along with the types with close to 100% confidence. Anything that isn't known ahead of time is clearly marked out as some sort of maybe JSON blob, which calls out danger in a really nice way. It says, hey, this area is particularly dynamic. You'll have to be careful with your code. So let's take a look at what it's like to actually explore an API using this catalog-based approach.
And the first thing this chain is going to do is we're going to subscribe to Salesforce. And inside of Salesforce, we just want to know whenever an opportunity has been created. And whenever it's created, we'll go ahead and pull out the amount. We'll pull out its ID, whether it's been closed and won, the name, as well as the stage name.
Okay, we've explored an API, and now it's time to actually write some code and make some API calls. And just as a reminder, we are trying to enrich a GitHub user who is signed in, get their verified email, and to go enrich that and get some information about their company. So having read through the documentation on GitHub, I find the endpoint that has the data that I care about, and I'm going to go ahead and just simply fetch that. It's not a big deal. I will await the response. And in this case, I'm cheating a little bit. I'm making an assumption that the JSON is an array, not an object. But maybe GitHub stocks are pretty good. So then I go through and I iterate through the addresses, trying to find one that has been verified, and I pull the email off of that. If I got an email successfully, then I'll go ahead and pass that into Clearbit, and I'll get back my enriched information. Along the way, you can believe that I am going to be console.logging a lot, because documentation is one thing, and then the actual shape of the data that we get back is oftentimes another. And it turns out in this case that I didn't realize that there was maybe a primary field, which is a Boolean. So what I'll do is go back to my code that I wrote previously, and I'll modify the assumption so that I'm not just pulling out the verified email address, I actually want the one that is the primary verified email address. And this highlights a secondary challenge, which is that confirming our expectations can be quite difficult because those expectations are scattered throughout the call sites of the client code. I didn't know that there was a primary, or I didn't know that it was an array instead of an object. And then there's a lot of code that relies on that in a way where the expectations are not made explicit. So it's really nice if you can actually extract that so that you have your expectations in terms of inputs, outputs, and transformations all bundled together. And then those inputs and outputs should largely be based off of the API catalog. So in this case, we're going to say, well, I have a specific named action, which is I want to enrich a new user who signed in via GitHub. Given their GitHub user ID, I want to reach into the API catalog for a query that will give me all of the GitHub user emails. And then I'm going to run a little bit of logic on that to extract the verified primary email. In this case, it's JavaScript, but you could imagine if this was a service internal to your company, you might have it all written in Ruby or C#, whatever it might be. But then you're going to take the result of that and then reference the catalog once again, pull out the enrich email with Clearbit function, and then you'll get some company information out. And this is nice because now we have taken that action, which is multiple steps and transformation logic, and we've kind of bundled up into its own little standalone package. And so we've captured the source from the API catalog, all of the functions that we're going to be referencing. We've captured the input requirements and the output requirements. And we can also do this during development.
And this will allow us to actually explore and iterate on our integration bit by bit, and then we can visualize the output instantly. So let's take a look at what it's like to actually visualize and iterate on the data during development.
Real data flows through here now. And so once again, if we come in here and we pull our picker in, you can see that we're no longer seeing the preview of mock data, we're seeing real data. So if I want to pull out maybe the name here, you see that that gets assigned in here just as we'd expect. Similarly, this is also really nice whenever you're playing with the individual forms. So maybe I want to try out this block and I need a track ID. I can actually just drag from this block and say I want to pull this ID here. And this works for all sorts of values. Okay, we've worked our way through the API documentation. We've built something that seems solid. And now it comes time to actually deploy this to our different clients. But there is a challenge there, which is we might have more than one client. We might have JavaScript, or we might want to allow someone to sign up via GitHub on the iOS app or on the Android app or the desktop app. There are lots of scenarios where we might want to reuse this specifically crafted action. And the challenge here is that the logic for that action is deeply tied to our implementation, which includes both the language and the runtime. So even inside of JavaScript, maybe the transformation logic is relying on some Node crypto library that isn't available in the browser. And so that means that each of these clients effectively has to go in and re-implement that transformation logic and deal with testing and exploration kind of all on their own. Whereas if we have this action defined and we have a separate service where we are locating all of these, we can basically take this well-defined input and output and say, well, we know enough about this and how to make these calls on these different platforms. Let's generate a really high fidelity package that can be used from Dino or from TypeScript or Swift or even Ruby. Whatever the endpoint is, you can say, look, we have defined our actions that are available for our whole team in one place. Here's all the documentation, here are all the types, here's the package that you can use. And this kind of centralizes everything, including definitions and logic into its own service. And that service can now rely on the API catalog as the source of truth. So you can generate all those nice idiomatic safe bindings. Those packages make it much easier to use from something like Swift, which wants to have significantly more type safety than maybe some of the other options. And this also means that one action is now shared and reusable across multiple platforms. And you don't have to worry about maybe the iOS team didn't implement it quite the same as the React Native or the JavaScript team. And so some of the users who signed up via the iOS app have very different company data than they would have had they signed up via the JavaScript app. And this also means that because we have named integrations, which are these series of steps, we can actually track metrics. How often are they being called? Are they expensive? Are they slow? How are they affecting our user experience? You can enforce usage limits and say, well, it seems like this client is calling into this specific series of actions a bit too much. We should go ahead and throttle that. And if the time comes when you need to upgrade and maybe add some new higher fidelity metrics to your apps, you can track down all of the different clients. Just keep track of who's calling it in and have them send in a user agent string. And now you know, oh, someone's using our older package. So let's take a look at the experience of actually publishing a package of a collection of actions and then consuming it inside of something like TypeScript inside of VS Code.
I'm going to go ahead and publish these changes to npm and give my API key. That'll go out and create a new package. It's published now. And we see that our package is published. I'll go ahead and copy this and install it inside of my project. And now inside of my project, I can go ahead and import everything from my package. So now I should get full autocomplete. I see all of the chains inside of my package are listed here, along with full TypeScript support. You can see that I get nice autocomplete. And it's nice also that my doc string comes through. So it's a nice little human level of documentation. I'll go ahead and enrich Daniel here. And I see that this is a promise, so I'll go ahead and await that. And now whenever I ask what's on my enriched object, you can see here that I have the GitHub email as well as the Clearbit block. And I can go ahead and get the data, and maybe I'll get the Clearbit, and let's go ahead and pull out the company logo. So this is effectively go into this user's GitHub, grab their email, and then let me know what the logo of the company they work at is. All right, so we've published this. We're consuming it from lots of different platforms. The next step is basically we really hope
We really, really hope that we caught all of the edge cases and based off of the input that we tested with. But this is very, very rarely the case, and almost inevitably something will go wrong, and then you need to debug. But debugging API integrations is particularly difficult. Rebuilding the sequence of events of what happened effectively goes something like you check the logs, hopefully you have some logs, you find some calls to one API, you find some calls to another API. It's not always clear that they were related. Maybe there are lots of them that are interleaved, maybe there are some that are happening simultaneously. Trying to figure out the linear step of sequence of events so that you can debug what actually went wrong based off of the logs oftentimes takes quite a bit of work. And then once you have finished that reconstruction of what actually happened, you need to figure out what expectations did you have about the data and the transformation that you were doing that wasn't actually matched by reality. Maybe it's nullable fields, or you weren't authorized to get the user's email. Or maybe you were authorized, but you didn't realize that emails could take on a certain shape, like they have a plus in them, which is absolutely valid, and every service should allow users to sign up with a plus in the email. So there are lots of expectations that you might have that are actually not mirrored by reality, and you didn't trigger them during your cases that you were testing with. And reproducing this is typically a nightmare, because the data that flowed through your system at the time that you were making the API call might not have been logged. The provider certainly doesn't remember the time that you called it. And so you do this kind of partial best effort reconstruction based off of the logs of what the state was and inputs and outputs. And what this generally looks like is that you didn't log enough. And so you push some more logs to production and you wait to see it again and you hope that you've caught enough. And maybe you didn't, and you do this again and again and again until you have captured enough of the inputs and outputs required to reproduce enough of the problem so that you know what your expectation mismatches were. So this is the third challenge, which is that debugging the exceptions in this case can be particularly difficult, especially depending on the nature of the API that you're dealing with. Whereas if we have these named actions, what we can do is actually attach some kind of metadata to them, where I can say, this enrich GitHub user action, I want to attach a data storage policy. I want every time it's called, I want to capture all of the inputs and all of the outputs from every API call. Or maybe I only want to do that whenever there's an error, store it in memory, but if there's an error that happens, go ahead and commit it somewhere. But only store that for 25 days. And also, this may have personally identifying information, which is affected by the GDPR. So we need to make sure that we're storing this in a safe way. And so we can take all of these concerns and simply attach them to this action, and then push all of that down into the system to make sure that it's being handled by a specialized system so we don't have to worry about it. And then from then on, our clients are just simply calling them and getting this really nice idiomatic experience. And all of the back and forth between the actual APIs is happening in this integration as a service. Any sort of slow API calls or error traces can be stored. They can be managed appropriately for HIPAA or GDPR. And so we have these nice instant repro cases. We can instantly capture all of the results, which means we have instantaneous reproduction. So any surprising inputs or outputs, we can capture, we can debug, and we can actually save for future tests. And because we're working at this much more clearly defined level of make this API call for this specific intent, do these transformations, and each step has a name, it's very easy to tie together a story of saying this step happened, and associate the API calls with the code that's actually operating off of it. So let's take a look at what trace-based development actually looks like with automatic reproductions. And I look at my enriched GitHub, I can actually see a list of traces. So these are all the times that it has been called before. And so here we see it was called with Daniel's input. We see the resolved email, as well as the enriched data here. We also see all of the previous calls to the actual APIs. So if we want to see the raw API calls, we can actually see them, as well as some overall information here. If, however, I come in here and I go ahead and run this with saw, whenever I come back to our trace, I see that there's actually an error here. And this is really nice because even though I called this from inside of my JavaScript code here, I can have a full trace of exactly what happened, including what went wrong. So whenever I look at the clear bit, I can see that the value for this email was actually empty. So let's go ahead and come in here, and I'm going to use this as a mock. And I want to know maybe what's going on exactly.
So I'm going to change email to go ahead and be a computed value. And now whenever I drag in the email here, I can say, let me get the email as well as the bio and the login. And I can see that for this particular trace, even though it was called from my JavaScript, I can actually see what's exactly going on here, where they have a login, but their bio and their email are both empty. So what I'd like to do is make it so that by default, the email is going to be equal to the email here. However, if the email is trimmed and equal to that, or if the email is null, then I simply want to return early and I don't want to run this. So that way there'll be no error, even though we won't get any enriched data back. And so I can see here that this is true and this is not being evaluated. So now if I come in here and I try this again with saw, we can see that the GitHub email runs just as we expect, but the clear bit was never executed because we terminated early here.
All right, so we've pushed this out, we've debugged it. At some point, we're going to have to upgrade the integration. And there are two kinds of upgrades that can happen upstream, one of which is an additive change, which is no big deal, right? Old clients ignore it and new clients opt into it. Breaking changes are much more difficult, especially in that fetch-based world where we just have URLs as strings that we're hitting. In particular, we have to find all of the usages of that broken API, the one that is now being removed. We have to communicate what the breakage actually was and then update the expectation of all of the code around it. And this means that over the long term, maintaining up-to-date clients is really difficult. YouTube moved from V2 to V3 of their API, deprecated V2, and anyone who was on that had to rewrite their integrations to get to V3. Every single client had to be updated in order to get access to the same data that they were getting previously. And that can be really difficult to find, to make sure that you have found all of the references. That can be nerve-wracking. Whereas if we have this much more named approach where we have an explicit action that we're trying to make available to our clients, let's say, for example, Clearbit no longer offers the company information whenever we're enriching a client's email. Well, what we can do is say, well, there's another company that does do that. And I can take those traces from before that we had. And because I know the shape of the data that's expected to be returned, I can go in here and I can use this other company's API and plug that same data in, and I can then push that out to our integration as a service, and all of our existing packages just continue to work. So we're able to swap this out in one place rather than in different places, including some older clients that we maybe can't update anymore. Maybe they're iOS clients that have been running for 5 years. And this leads me to one other possibility that I'm pretty excited about, where the kind of current cycle that we've talked about is, we build an action, we document it, and then we track the results. But going back to our initial documentation question, I would ask, who is the best at example-driven API documentation? And I would argue that it's Stack Overflow. Stack Overflow is this crazy community-driven site where people say, I'm trying to do X, and other people come in and say, well, here's how I would achieve X. And it's hugely successful, as we all probably know. So I would ask, why aren't integrations more like Stack Overflow meets NPM? Why can't I just post a question and get one of these reusable bits back? And part of it is because of, like we talked beforehand, implementation is locked into one language. If the answer is in PHP and I'm writing in Ruby, I have to kind of translate it over, including finding the right libraries or packages or rewrite the encryption, whatever it might be, in a way that makes it quite difficult. And even if it's in the same language and I copy and paste it, it kind of melts into my code. And if I were to change it a little bit to fit the last mile, those tweaks are not pushed back to the Stack Overflow. At best, maybe you're a good citizen and you go and you comment or you add a new answer. But a high percentage of people, more than 99%, are unlikely to go and do that. But in our case, we don't have that problem because we have explicitly defined the interfaces for our integrations, as well as made the logic kind of standalone. We don't have to worry about that. So we can build an action, document its usage, track the results, and then share it with other people. Just like we saw in that initial demo, I had a list of blocks and actions that other people had built. And so I can say, hey, is there an example that includes this keyword in its description or references this field or uses this function? If so, let me take a look at it and see if it does what I want it to do.
And if it does, then great. I can just bring that in and use that in any of my clients. And maybe I tweak it for the last mile again. Or I change it to handle some new edge case that wasn't there before. And then I can push that up so everyone else can benefit. And this is because we've captured the intent of the action. We have the individual steps, and we know what is an API call to make a change, what is to get data, what is the transformation of it. We have the ability to optimize it better. We can share our enhancements to it. So it's almost as if Stack Overflow had importable examples. And of course, we can use this both internally within our team, but I'm really excited about being able to do this across the entire internet, the entire community, so that an API provider can say, hey, here are dozens and dozens or even hundreds of examples of how to use our API. Maybe search through there and just go ahead and import that into your code and you're up and running. One last point I want to touch on is the ability to stay in your own domain. Because we've wrapped up these actions into atomic shareable units, it means that we get to control their interfaces. We know their inputs and their outputs. And this gives us the ability to actually hide implementation details and data that we don't care about or that our team doesn't care about. In particular, maybe there's an API call to create a Zendesk ticket, and all your company teams care about is providing a subject and a body. That's it. But the Zendesk API requires you to fill out lots and lots of other fields. Well, you can capture the part that you actually care about inside of a create ticket action. And you can implement all of the implementation details that you care about, or that Zendesk cares about there, and not have those concerns infect the iOS client or the JavaScript client. And this is already what you would typically do. This is an API team inside of your company who says, well, we have other teams who need to interact with this external API. We'll put together our abstraction, our common language for dealing with it. To give you an example that I live in is pushing files to GitHub. In the ideal model for me, I know that I have a GitHub repository and a branch and some files. And I want an API call where I can just push these files to the repository. It'll create the branch if it doesn't exist, and the files get there. That's it. In my mind, that's a very simple concept. The actual implementation, if you bring in the entire provider's domain, is quite intense. This is not even everything. This is a lot of work, including computing the Git hash and including a null byte at the end in order to match the provider's domain, because GitHub does a great job of modeling the Git API underneath the hood. But that involves things like nodes and refs and heads and things that I'm not thinking of. I'm thinking of a repository and files. And so to visualize this is what that actual action looks like here, where you can see it's quite intricate. There's lots of input, lots of computation that happens along the way. But after we have modeled it in our domain, we can see that we get a nice package with autocomplete, with typed inputs, where we simply say, here's the name of the repository, the owner, and some tree files. And that's it. We get to stay in our domain. That's a huge win. So wrapping up, what are the goals of our integration? We just want to build faster. We want to move with confidence. We want to be able to debug with real data and not imaginary data. And we really want to minimize the future maintenance whenever there's some upstream changes. And we want to be able to stay in our domain and worry about our problems rather than our provider's problems. And the challenges here are effectively that exploration is going to be difficult. Confirming that our expectations are correct is difficult. Debugging is difficult. Maintaining up-to-date clients is difficult. But part of the way that we reconcile that is by extracting all these implicit pieces and saying, look, here are the components of integrations. We have an API catalog that is 100% or as close to 100% true as we can get it. Based off of that, we have built these individual actions with some little bit of glue logic so that we can say for our company or for our project, these are the verbs that we care about. We can then publish those to all the different clients. They can consume it from there. And we have a centralized place to monitor the ingress and egress of data, the client usage, reproduction, like all of that stuff can be centralized in a really, really nice way. And the thing is, this one client works for all APIs. So an API provider simply provides their catalog, and that's the source of truth. That's their job to keep that correct.
but everything else automatically works. You plug that into one side of the machine and all of the other stuff just magically works. And this means that it is vastly less work for the API provider as well as for the consumer. Not everyone has to build their own super high fidelity API client for every single platform. It's just simply, here's the data, your tool can consume it, and you can transform that, map it into the actual bits that your team cares about. And you get to maintain your abstractions, which is nice. So SaaS is really powerful, and APIs are wonderful. We're able to farm out a lot of these different concerns. But integrations with them are still very costly, both to build and to maintain. I personally have spent a lot of time building, debugging, maintaining integrations, and I am pretty sure that users have seen errors that were directly the result of me overlooking some assumptions. And I think that with something like this approach, where it's much more explicit, we have named components, we have confidence every step along the way, and immediate reproductions, we could actually achieve something like a 99% reduction in both the time and errors. So the experiment that I'm working on is not ready for widespread use, but I'd love to get some early feedback. So
I'm sure you can tell in which order I've taken the videos by the amount of sweat on my face. But I guess that's what it's all about. So many hard workers here on this conference. So join me tomorrow. A big shout out to our sponsors, Tova digital agency from Bregenz. They are building experiences for all types of small, medium enterprise businesses and also industrial companies. And also we want to thank Arculpa, a software agency that is specialized on advanced software, apps and big data. We want to thank Antiloop, software company that are building complex infrastructure software. We also thank Gebrüder Weiss, one of the leading logistics companies in Europe. We thank Bloom, company that makes all the kitchens work by delivering metal parts and clutches for your kitchen. And last but definitely not least, we thank a lot Fusonic. They are building advanced software for small and medium enterprises for the region and above and beyond. Another important partner is Illwerke VKW. I'm standing here right in the middle of one of their territories. They are not only building cable cars, but they mostly sell electricity and make everyone's internet run smoothly by delivering backbone. Also, we want to thank Vorarlberger Wirtschaftskammer. They support us by giving tickets to students and scholars. We want to thank the Chancenland Vorarlberg provided by Wirtschaftsstandard Vorarlberg. They are making our face to the world nice and shiny. Also, my company is contributing, Stars Media, online marketing and performance marketing agency, and also Smart City Dornbirn and their team. They are doing a lot for the region and also for building a new municipality that is making all the contacts smoother and easier. And very important, all of you guys, only with you it's possible. So spread the word. Thanks a lot for being part of this awesome event, and be sure to join us at the online opportunity.
For those who join our bike and hike event tomorrow, see you there at 10 o'clock at the Rathausplatz in Dormen. For everybody else, thank you so much for your support and your trust in us. Hope you liked our format. Have a nice evening. Bye.
Stopp.